Welcome to the stream. If you're new around here, be sure to hit that follow button. Wait, just kidding. I didn't earn it yet. Check out everything I do. I promise. The Discord has a ton of wonderful people. You'll have a ton of fun here. I promise. And it's a great time. So definitely check out the Discord, and you'll get announcements every time I go live, like the announcement I'm writing right now. Because right now, I am live at twitch.tv/Lenser. And if you didn't already know, we're writing an assembler. I could probably change the title of this stream. I don't know what it is. Let me check that out. But yeah, be sure to join the Discord. There's a ton of stuff like this announcement I am writing right here. And there's a ton of great people, lots of good stuff, and you can learn a lot. So be sure to join. Yeah, we're doing compiler dev. That's fine. That's a good title. Whatever. Alrighty. How's everybody doing? How's everybody doing? Let me know. Welcome, everybody. Welcome. We are here. Make sure I can change things and not blow everything up. It seems to be working. Perfect. Whoop. There we go. Oh, I forgot to put up my my little window. Here, hold on. Mini Lisper says, Happy Sunday. Thank you. I appreciate that. Something like this. And you might see a little white square. Okay. Let me know if there's a white bar anywhere here. There shouldn't be, but just let me know. Okay. Thanks, everybody, for putting up with that. We should be set up now and ready to go. As I said, be sure to join the Discord if you haven't already to get announcements every time I go live and never miss it again. That's for the YouTube video. Now, let's get right into it. If you don't already know by the title, we're going to be doing some assembler today. Not assembly, we're going to be doing the assembler. And I've already started, if you haven't been following in the Discord, I've already started this branch, which we can take a look at, I guess. Not Emacs. This branch of this PR. And you can see it's quite extensive. And it's adding an object file backend for x86-64, which means that, if you don't already know, the intercept compiler generates assembly by default at code.s, and the assembly then has to be assembled into actual machine code. And although we do have to do things like figure out what assembly goes here, we don't actually do any assembling into machine code, right? And we're leaving a lot of stuff here for the linker as well. For example, these global definitions are all for the linker to tell the linker that these have global bindings instead of local, which is the default. For example, event and quit and window don't get global bindings. Now, something to keep in mind, this then gets assembled into an object file by as, and we can actually do that and just use as. If you don't know, as is the, I gotta pass it, like dash version or something. It's the GNU assembler, part of GNU binutils package, and this is 2361. Right? So if we use as, we can take this assembler that intercept generates, right? And this is a little small, I can make it bigger. There we go. We can use this assembler to generate an object file. You can see we get some warnings because the assembly we generate isn't perfect, but there's enough data there because we want it to use the default for sub, and that's why there is no mnemonic suffix, but don't worry about that. Basically, we now get code.o, which, as you can see, is a COFF object file, which has 3 sections and 25 symbols. COFF stands for Common Object File Format, and it's used on Windows mainly, only Windows, really, because it's kind of it's honestly a nice object file format, and I don't know why more people don't use it. Because writing like a loader for it and writing things for it is nice. I don't think all the Windows extensions are nice, but COFF for object files is pretty nice. Seems ironic to call it COFF. Maybe. This definitely, by the way, says COFF object, common object file format object file. So we have a COFF object file, and we can actually use object dump to take a look at this thing. If you pass -x, then you get to see the different headers. And for example, looking up at the top, you can see it's a PE x86-64 file format, which means that it's basically portable executable, which is the executable file format for Windows. This is just the GNU way of saying COFF, and for an object file. And then x86-64, this is obviously the architecture that Intercept is targeting mainly right now. And there's also some interesting insights I've had while writing this backend. Anyway, code.o, this is just the normal assembly into an object file, and you can see we get this thing that has relocations, debug information, symbols, and locals. You can see it has line numbers stripped apparently. It has a bunch of zeros here because there's no optional header. There's the data directory, which is again a bunch of zeros because we don't do anything with that. And this is really executable only, not object file. And then we have sections. If you are familiar with programs and how they actually work under the hood, executable files, you'll feel familiar with .text, .data, and .data, and .bss. I can't speak today, man. I don't know what's going on. I gotta take it slow. So there are different sections within this object file. They have different names, right? And .text is the code section. You can see it has code within it, and it's read-only. .data has initialized variables. So you can see this has a size within the file. So this has 160 hex bytes within the file that has to be copied into memory for this program to be able to run. And that's the data that needs to be initialized. And the file offset is where it is, the byte offset within the file. .bss, you'll see, has nothing in the actual file. And there's also just nothing in it because there's no uninitialized variables as far as I know. We didn't leave anything uninitialized. Poggers. So with these three sections, you're able to load these into memory. Mini-Lisper says, so what was the main factor over using COFF over maybe ELF file format? We'll get to that, but hold your horses there because we are not doing anything like that. This is just going through what my machine, when I use as to assemble code.s, which is the output of Intercept, if you're familiar, into code.o, and then we just use object dump on that. So we're just looking at a COFF object file, right? Next, we have a symbol table. Symbol table is exactly what it sounds like, a bunch of symbols in a table, and they have an index. So for example, the first one is a fake one, which is usually for making sure that a zero referenced symbol isn't valid. It's kind of like how null pointer dereferencing is bad. There's no actual reason it has to be bad. It's just because that's a good way to detect errors, right? Anyway, then they have a file which just has the source information of how it was compiled. Or assembled, I should say. And then at offset 2, this is where the fun stuff happens. This is SDL event quit. And if we go take a look at the file that this is from, you can see SDL event quit is the first actual variable declaration in the file. Would you look at that? And SDL event quit, as you'll notice, has offset 0. but SDL init video has offset 8. And that's the next initialized constant, right? So these numbers here are offsets within the section that these symbols are defined within, and the section that they're defined within has to do with the sections, the section table, right? And these are all in section 2, which is .bss, as you can see. Or at least that's what it looks like. So they're probably initialized at runtime. No, I remember now. In COFF, sections are 1 indexed because section 0 has a special meaning, but the actual sections in the file, they're 0 indexed. So don't worry about that. I know that's a little confusing, but section 2 is actually this one, the second section. Because section 0 is actually section absolute or something like that, and it means that the symbol isn't tied to any section and it has a virtual address. What's the align field in the section? It says Milaudi. The align field is an exponentiation of 2. So this is 2 to the power of 4, right, for all of these, which is 2 times 2, 4 times 2, 8 times 2, 16. So these are all 16-byte aligned. And the reason that these have to be here is because the sections describe what needs to be loaded into memory at runtime when you execute this code. And when you execute this code, these sections have to be 16-byte aligned in their loaded memory address, which obviously isn't encodable in the virtual memory address or the logical memory address, because neither of those actually are filled in yet, because this is all relocatable code, which I don't think it says. Yeah, it has reloc. So there's a bunch of relocations because this is relocatable code. And relocations basically mean that we are taking some value within the machine code or within a section, right? Within one of these sections data within the file, the linker needs to go through and fill in, okay, this symbol is going to get placed at this address. So relative to this, we need an offset of OXD, right? So add OXD to the virtual address filled in for .data, and then go through and fill that value in at this relocation, which is going to be somewhere in the .data section or somewhere, right? Or the .code section, etc. And you can see we create, not we create, but relocations are created for variables from intercept, those globals and locals that we defined, as you can see. And this is to make it so that the object file doesn't have direct memory addresses hard-coded into it, and then you have to go and like change those or fix those. There's no hard-coded addresses. Everything's an offset from each other. So then whenever you actually go to load them in memory, you give them an address and then fill in all these offsets with the difference between the two loaded sections. Does that make any sense? Hopefully that makes sense. I know we're going over a lot here. So that's just a basic object file that gets generated when we would do the normal thing of using the assembly output code.s to generate an object file. And then we would use LD with a bunch of like linker magic that we're going to use GCC for, right? And then that would go into code.exe. Oh God, it didn't work. Oh yeah, because this is the SDL example. So excuse me, I've got to do this stuff to link with SDL properly. And I can use the object file instead and then pass in that -v. And this is quite a bit, but if we just take a look here, you should be able to see eventually if I can find it. Jesus. What did we end up doing? What do we have? Compiler path equals, yes, bunch of path. Here we go. LTO wrapper. So this is LTO wrapper is basically link time optimization wrapper. This is passing stuff to the linker. And we end up passing through, as you can see, lkernel32, lmodename, all the linker stuff that goes here. And this ends up generating our final executable, code.exe, right? No such file or directory. Seriously? Why not? Oh, I didn't name it. That's my bad. There we go. And now you can see it's a PE32 plus executable for x86-64. Sarade says, oh god, a GCC command line. Hey, what's up, Sarade? It's so good to see you. Dmitry Kubishkin and Airbus, thank you so much for the follows as well. Appreciate you all around here. But yeah, so as you can see, we can take our code.s that intercept generates, right? We can generate that just with by invoking intc with a file, right? And this generates code at output file path code.s. And then we can use as to assemble that into an object file, right? A COFF object file on my machine. And then we can use what is effectively LD, but because of link time optimization and complicated stuff with runtime, or not runtime, but system libraries and linking, what we have to do is something like this so that we can actually link with everything properly. And you can see everything it's doing. It's quite complex. We don't need to see everything it's doing anymore. And then we can take a look at code.exe and we actually get an executable. And we can even use object dump on that code.exe and disassemble the main function. Why not, right? It's quite long. And as you can see, we have main, and we have our variables that we're loading the address of. We are calling SDL functions and loading string literals, which have got their RIP relative addressing filled in, as you can see. Because if we do this for the object file and compare, whoa, what did I just do? If we do this for the object file and compare main, what you'll notice is that everywhere where there were numbers before, there's not here specifically, these are fine because they're just fixed offsets. But as you can tell, there's no numbers here, which is a problem, right? We actually need these numbers to be filled in, these zeros, to be filled in with the addresses to, which is what the linker does. It goes through the machine code using the relocation entries of the object file and fills in these things. These little bits of zeros that need filled in, right? These here, stuff like that. Hopefully that makes sense. And then you can reference these things in that way. So that's what the linker does, goes through the machine code over here on the left, which is this assembly. Also, all of that is part of why I'm saying that writing a linker isn't worth it, because you'd have to link against e.g. CRT-begin.o and 50 or so libraries that may be anywhere on your system, and to my knowledge, there's no standardized way of finding out what you need to link against and where all of that is. Yeah, we just have like bundles. On Windows, it's easy because everything's a DLL. Even like the kernel libraries and stuff, right? Even WinAPI, everything's a DLL, so not too difficult there. You just make them external symbols. But we would have to do like trampoline stuff, like we saw in the executable here. For example, when we call SDL init, see it's doing this actual DLL import thing where we call the imported version of SDL init, which is actually a jump table that the linker then fills in at runtime. And it's a mess. I wouldn't worry about it too hard. So that's object files, and it seems like a lot, right? It's not, because I'll show you what we can actually do is we can get back to, I think it's in here. Just give me 1 second. We can enable the generation of machine code in the x86-64 backend. And oh boy, this does a lot. Remember those 3,000 lines from the PR? That's all within this if-def, baby. Are you ready? Are you ready? Okay, so now we're not going to do the SDL example because that's quite complicated, right? Where is it? Here it is. We're going to do an example like simple pointer. Let's do that, right? Simple pointer. And let's go look at simple pointer too. So simple pointer is a function in intercept that is called on, and it basically takes in a pointer to an integer, assigns 69 to the integer at that pointer, and then that's it. And you can see that clearly. We have number, bar, which is passed the address of number, and then we return number from the program, which means that the program should return 69. Are all functions that start with imp Windows syscalls? No. Syscalls are not functions. Okay, so with that, this simple example, right? We're going to just compile that. And you can see it looks very similar, but if you'll notice something, we now have object.o and out.o, which are both in the output now. I don't know why 15 hours ago is what it's saying, but these should be brand new. We have object.o and out.o, and if we look at what these are, we have a AMD64 COFF object file, which is exactly like we had before, if you'll remember. And then we have the ELF 64-bit little endian relocatable, which means it's an object file, right? It's a relocatable object file. It's not hard-coded addresses. And it's not stripped, which means it has its symbols, and it's a sys5 ABI ELF file. Pretty cool, huh? Pretty cool, huh? It's probably 15 hours old because the actual file it generates is out.object, not object.o. Oh, you're right. You're right. It's just the syntax highlighting really got me with object.o. I just saw these two and was like, oh yeah, one of them is .o and one of them is object. That makes more sense. Surrey'd coming to the rescue, fixing my streamer brain moment. It's actually out.object, which you can see is the same as up here pretty much. It's just, it has more things. And as usual, we can use object dump on these, and would you look at that? We actually get something. This is out.object is a PEX8664 object file. It has no characteristics, don't worry about that. You can see it has the 3 sections that are important, a BSS, data, and text. Very good, very important. They all have the proper permissions. I don't know if they have all of the proper permissions, but they do have all of the permissions as far as I'm concerned, that they require to be able to run. Maybe delete object.o just in case. That's a good idea. And as you can see, the symbol table, we have each section has its own symbol and auxiliary symbol to tell the section length. This is really for the linker and link time optimization stuff and debug info so that when we do the following thing, it makes more sense. I'll show you. And then you can see we have in section 3, which is, again, one index, so 1, 2, 3. This is BSS. We have number, an uninitialized constant, an uninitialized variable. And as you can see, we have an uninitialized variable number. Oh, it's working. And then in section 1, we have 2 functions, main and bar. And there's a maximum of 8 characters, which Microsoft likes that, apparently. They like doing that all over the place. Anj says, yo, what's up, Anj? But yeah, as you can see, the first 8 characters of bar are in here. I am Prozod. If you haven't watched Soding and his Porth series, I would recommend that if you have Python experience. because you could probably write a compiler in Python in like the next week if you really want, if you really get into that Porth series. But as for books and stuff like that, I think crafting interpreters is a popular one, the Dragon book. Sorry, it says, I mean, there's Lenser on YouTube. Maybe you've heard of them. They have a compiler series, IRC. That's a good point. If you go to YouTube, here, I think I remember it. Let me see if I remember this one. I haven't watched this guy in a while. If you go to youtube.com/@LENSR, right? youtube.com/LENSR, right? If you go there, I'm pretty sure that's it. Then it turns out this guy has like this whole, a playlist even. Don't worry about that. This guy has this whole playlist even where he makes a compiler like for fun, completely from scratch on YouTube. So, you know, this is probably a good source if you are looking into just how the basics of everything works and how to actually start something from scratch. But if you're just looking for like making something, then yeah, Porth would be a cool one as well. There's like an entire chapter on LR parsing. Yeah, actually the first like 5 videos after the first one are just an LR parser, which you don't have to know a thing about unless you want to write a parser generator. Exactly. No, Lens, I'm talking about something else. You're talking about who? Oh, you're talking about the Dragon book. I missed it. I'm good at that. I wouldn't recommend the Dragon book nowadays, candidly. It's way too mathematical, technical, and out of date. Some people are into that. But we do write an LR parser, basically. I didn't know that's what it was called at the time, but that's pretty much what it is. It's a shift reduce. I am Prozode says, okay, thank you very much. Awesome. Blit03, I am Prozode, Melody, thank you all so much for the follows. I appreciate it a ton. As you can see, on this object dump out.obj, right, which we've created with intercept, the intercept compiler, I should say, not with intercept the language, you can see that we have relocations for the number symbol and the barf symbol, which is really just the bar function, right? And then you can see that we have offsets from those, which are stored here. Cool. And the even cooler part is that we also have out.o. Now, out.o is an ELF64 x86-64 object file. And as you can see, it also has 3 sections that are identical because it's the same thing, but they do have different file offsets because it's a different format and different alignments, because these are just the default alignments for sections. I haven't set any alignment. So now ELF, right? ELF is now generating, ELF is the executable linkable format, if you don't know, and we are now generating out.o as well as out.object, and out.o is an executable linkable format 64-bit file, which contains basically the same data, but a little bit better. As you can see, we don't have only 8 characters per symbol, right? So we can get things like full debug info in here. And then we have the same relocation records, which are a little bit different in how they work, in that they have an offset, but then also this offset, because the program counter in COFF is actually counted from the current one like sensible, like a sensible person would, whereas ELF uses the Intel x86-64 style, where the program counter is incremented before the current instruction is executed. So it'd be like incrementing the pointer and then using the last value. That's kind of what happens in x86-64, and that also helps the cache and everything like that, because it can do reordering if it reads ahead, right? So basically, RIP gets incremented as before the instruction executes, which means that if you actually try and relocate something from an instruction, then you have to go off of the next instruction, which means that we need to go 4 bytes because this is a 32-bit displacement. You don't really need to know about that, but that's just something I ran into recently that let me fix it, having this -4 in here. Molly the Man says, how can you make it cross-platform? It is cross-platform, and there's many ways in which it is. First of all, right? We have the actual build system is cross-platform, and then we have the code written in a way such that multiple compilers that support multiple platforms is able to compile it. As for the source, if we're talking about the C code for intercept, right? This code is written not with the no-discard GNU attribute, but with a no-discard macro that when you have the GNU compiler, expands to the no-discard GNU attribute, and if you have MSVC, then it goes to the MSVC no-discard attribute and stuff like that. So that helps the code stay cross-compiler, which inherently helps it stay cross-platform. And then intercept itself, this code, making it cross-platform, is as easy as supporting the things that those platforms require. For example, Linux has the System 5 ABI and Microsoft has the x64 ABI. Those are different ways that functions are called and the way that parameters are prepared and where they go in registers or memory, where the return value goes, etc., how the stack is set up, everything like that. Sorate says, on Windows, is the symbol name actually truncated to 8 chars? It is. In the binary, or is that just object dump being weird? It is, because if it is the former, then that'd wreak havoc on any programs that actually contain multiple overloads of the same function. Yeah, I know. There's a string table in COFF. I just haven't made one yet. So don't worry, we can fix this. It's just that short symbols have inline names. Whereas in ELF, the string table is actually a sensible thing, not like another section table. So the string table in ELF, if we use strings on out.o, you can see these are the strings. And we can even do object dump on out.o and look at the, what is it? The strings. Is it dash section? How do I look at a specific section? -J. And I want to look at the string table. No? What? You're not happy with -J? You're not happy with -- section. Am I getting that wrong? Am I crazy? What did I just read? Am I crazy? Isn't there a way to do a specific section? There's not even -J here anymore. What am I on? Okay, maybe I'm crazy. I don't know. Maybe I'm crazy. Don't worry about me. It'd probably be easier to use hex dump. There we go. Melody, I don't think the order matters. At least they haven't in my experience. I think we can do -- disassemble equals main after, and it's fine. But yeah, as you can see, the string table is literally just null terminated strings in order. There's a 0 byte, which is the beginning of it. Then there's .text, null, right? And then there's .data, null. There's .bss, null. There's it's literally just a bunch of strings, and to access things within here, all you have to do is use the byte offset into this little table starting at this 0. Which is easy, right? It's a byte offset. Whereas COFF has like its whole own string entry system, and then the strings are actually stored elsewhere. So there's like a string entry header table and then a string. It's more complicated. Sorate says, I think you have to give it 2 options, i.e. -J and another option. Interesting. I see. So I'd have to give it like dash. Yeah. I don't know. It's an interesting one. But yeah, basically, we generate object files. All of this to say. And how we do that is we have to assemble things into machine code. Because, oh, that's one thing I didn't do. If we actually disassemble things... Why are you confused? Oh, I did dash. It's not confused at the file format. It's just not a good message. There we go. There we go. You can see that we actually have not debug information, but we have machine code here that, again, has relocations, as we saw in the object file. So there's zeros here and here. But this machine code has to come from somewhere, and it has to come from us. That's actually what the compiler now does. So if we take a look at the CodeGen backend, if you can't tell, there's no direction for today's stream, other than I'm going to write some assembler. Some code that does assembling. If we take a look at the backend, we have this basically a bunch of helper functions followed by a bunch of helper functions. So you know how we had the femit functions, for example, femit immediate to mem, and these are all directly correspondent. Sorry, that's bright. These are all pretty much directly correspondent to opcodes. This is the Intel 64 SDM combined volumes, by the way, which you can get by Googling. It's available online. Immediate to mem takes in an instruction, an immediate, an address register, and an offset. So the memory part is a register and an offset, which is this M part. And then you can tell that we don't have size here because we don't actually know what size to emit necessarily. We're just kind of going with the defaults as for an immediate. And for example, if we were going to move an immediate into a register, I guess that'd probably be more apt. An immediate to a register, right? You can see that we have a register size, so that will select our R8, R16, R32, or R64. So you can pretty much know that it's going to be OX88 or OX89 with some sort of mod RM affix and a rex.w possible or OX66 prefix. And we'll see that if we go mcode immediate to reg and we switch on the instruction, and you can see that a move instruction for R8, right, an R8 register, 8-bit register size, is encoded as, this is moving an immediate to a register, right? Not a register to memory as before, which means we're actually down here, move immediate 8 to register 8. And you can see that it is OXB0 plus RB and IB. RB refers to the fact that there is a RB encoding of registers. So to encode a single, this is another tab with the manual open, by the way. I think it's at the start of chapter 3. To encode, here it is, a single register, you can see that the lower 3 bits of the opcode byte can be used to encode the register operand without a mod RM byte, right? So this plus RB, as you can see, is the byte register, and the register field is the thing we're interested in, the 3 bits at the bottom of the opcode, which we are adding to, OXB0. And you can see for AL, we return 0, for CL, 1, for DL, 2, etc. And then if we set rex.b, then we can actually encode more things like SPL and BPL and SIL and DIL. Hopefully that makes sense. And then in 64-bit mode, instead of using these, we end up using these, and these registers go unencodable. Don't worry about that. What this means is that there's a number here. We add it to the opcode based on the number from this table. which is the RB encoding, right? The register byte encoding. And then we have an immediate byte directly following that, according to this, right? B0RB IB. And IB is just an immediate byte. It's what it sounds like. It's a byte in the object file. So then we are emitting machine code into a generic object file. You know how both the object files we're looking at look remarkably similar? For example, we can look at out.o-x and out.object-x, and you can see we have 3 relocations, right? For number, bar, and number. We have symbols for number, main, bar, and each section. And then we have 3 sections. And if we look at the other one, we have 3 relocations for number, bar, and number. We have symbols for main, bar, number, and each of the sections. We have the 3 sections. They're identical object files. They're just in different formats, right? So it says, oh God, Lamau, I'm looking at my compiler's object dump and some C++ templates generate rather horrible symbol names. Oh God, I can't even imagine. It gets bad enough with like a simple function and intercept. I can't imagine some C++ template horribleness. As you can see, they kind of share the same data. They're just different representations of it. So what I've taken the liberty of doing, much like GNU BFD, is writing my own generic object file format that I can then translate into the different object file formats necessary. For example, here is the code that generic object as COFF x86-64. It just takes an object file and a path, and it writes the object file as COFF x86-64 into path. I can put a screenshot in code review. I'll do it. But yeah, so we just write this generic object file, and then this generic object file gets translated into the proper object file. And the generic object file has, it's kind of just arbitrary, right? It has symbols, it has relocations, and it has sections. And that is all that it has. Object files are not complicated. The format that they are stored within is, right? You have sections, you have symbols, you have relocations. That's it. There's really not more needed than that. I'm excited. Oh God, what is that? Ah, yes. Oh no. What? Command line options, clops, positional, static, string, That's a good one. That's my favorite. This is nonsensical. Eel. Eel. L. I like the variability here. That's so awesome. Thank you for sending that. That's hilarious. As you can see, they're the same. So we just have, or wherever we found it, Lamau. So we just have a generic object file. And in x86-64 backend, if we look at the mcode, not the mcode, but the actual mcode immediate to reg function, for example, you can see that move instructions from R8, we already kind of know which encoding we need to choose, right? We know that we're doing a move from an immediate 8 to an R8, which means there's only one possible encoding for this instruction, which means that we know how to emit it by emitting the opcode and then the immediate 8 byte, right? With the proper register encoding encoded. And then I just noticed that there's something missing here. And that's something that's interesting that I definitely need to fix. And it's basically this. Because if we are moving, remember RB right? RB, this may need the rex.b bit set. If you remember, this rex.b bit also matters because 7 may mean two different things, right? It may mean dill or it may mean R15B based on the rex.b or something like that. I don't know what's happening here. Yeah, that's right. These aren't encodable, so yeah. I remember now. Basically, rex.b is needed to encode these extra registers, right? And there's no rex prefix here ever, but we need to fix that. So we need to write the rex prefix, but only if we need this top bit set. Which means that it's going to be R8B through R15B. Which means that the top bit of the register, yeah. So destination reg bits is actually just reg bits on destination register, as far as I know. That should be fine. So reg bits is a Intel way of encoding registers as far as the mod RM byte goes. And if we take a look at the mod RMness, you can see that there are two 3-bit sections that refer to register, RM, and there's a 2-bit section called mod. This is how the encoding works. Mod has these different 4 rows, and then RM has the 7, or what is this? Yeah, 1, 2, 3, 4, 5. Yeah, the 8 rows within each mod. So there's 32 full options for RM with mod combination. And then the register, the other section, means something else depending on the time, right? And for example, in move, if we take a look at something that actually deals with memory, then you can see that they have something called op encoding, which is MR. So if we move register into register memory, and if we look at MR, the operand encoding says operand 1 is in R/M field, and it will be written to, and then operand 2 is in the register field of mod RM, and it will be read from. If we look at the register field, you can see that we can write these registers with these values, etc. I know it's complicated, but it's an assembler, right? And we can just get the reg bits. I think we'll just do it because there's no reason not to. Yep. Destination reg bits. Cool. So now I have this little helper to construct a rex byte, and you can see that B is down here in the bottom, you can see that B is the 4th argument, and that's why we're passing the top bit of the destination register based on that. You know that we already did this if, so we could just pass true, but it's this kind of makes more sense semantically, I feel like. So, where are we at? Yes, so now we hopefully will encode this rex prefix in this scenario, because we just need it, not the rex.w prefix, to make it 64-bit, which means that the first operand would be true, the first not operand parameter. By the way, I probably went in the wrong order, but there is these things called opcodes. Your computer executes them in order, and they are bytes in memory. This is their layout because some of them are multiple bytes. There are optional prefixes. There is the literal 1, 2, or 3 byte opcode. There is the mod RM byte, which is if required, the scale index base byte if required. These are the layouts of those. There's the displacement, which may be 1, 2, or 4 bytes, or there may be none, it's optional. And then the immediate, which is 1, 2, or 4 bytes and is optional. Yeah? And some take 8 bytes. That's right. And in this case, you can see that the immediate 8 goes after the opcode, and that's why it's in this order. Hopefully that makes sense. I know it's not a great introduction. Gus12FR and Shalom, thank you so much for the follows. I appreciate it. But yeah, so this is an assembler. It's very much similar to how we would do femit to reg. And in fact, we call it from there, right? And instead of emitting the assembly for the instruction and then the operands, right? We just emit the machine code using mcode. Hopefully that makes any amount of sense, because that's what we're about to start doing. So if we run somewhere, if we run intc on something that isn't super simple, like let's try greatest common denominator. Okay, what do we actually get here? Oop, I cleared it. You can see that could not find symbol referenced by relocation .l3. Okay, so this is something interesting. We are not creating labels to jump to, and we are not creating the but we are creating the relocations necessary to reference them. So we're trying to jump to a symbol that doesn't actually exist in the object file. And luckily, generic object lets us know about that. Nyan108, thank you so much for the follow. I appreciate it. Okay, let's do this. What's going on here? Let's make this compile, because it's rather simple. There's nothing here I don't think would be too crazy. We have subtraction, we have return, we have call, we have branch conditional. I think all of these are, we're able to emit these. And in fact we are, but we're getting stopped because we could not find symbol referenced by relocation L3. So we need to create a symbol for this label because it's referenced. Where do we emit labels? We can see that block name is assigned the label thing, but where's it emitted? Okay, here it's emitted in emit block. In emit block, we should probably just add our little ifdef. And this is not going to be how it will be forever, as in eventually these will be two entirely separate backends. But right now in the compiler, there's kind of an architectural flaw where a literal architectural flaw. Architecture right now is assumed to be unique per backend. This is false. We may want an x86-64 backend for gas, NASM, ELF, COFF, GObject, etc., right? We may want to have a different backend for each of these, but all of them for the x86-64 architecture. So a backend does not necessarily have a unique architecture, which means that the kind of current code layout where the architecture is mingled in with the specific backend, that's something we have to fix because the backend needs separated and from the architecture. That way we can use code for an architecture across all of the backends, or at least use some code, because we don't want to rewrite everything every single time. So that's definitely something that's on my mind. Anyway, I've kind of hacked in this little thing, context object, which is our object file, our generic object file that we're creating, right? And what would I like to do? Context object has, if I enable autocorrect basically, auto-suggest. What is this called? I'm blanking. Basically, I'm pretty sure we have to add a new symbol, which is, it's just a vector of symbols. So this is going to be sim or something like that. And it's going to be a G-objective symbol, a G-object file symbol, which we're going to start as all zeros. Now I actually want to look if I've done this anywhere else, because I have to have created symbols somewhere. Okay, here I create symbols. Let's copy this. Then we'll go look what it means. Okay, we have symbol type, which is going to be a G-object symbol type. I'm pretty sure it's going to be static, but it may be external because it's just a label, much like a function is. So if it is external, so maybe it's not necessarily a function, it's just, well, it's a label. We're going to go with symbol type external for now, even though it's not perfect. What's the name? The name is the block name data, as far as I am concerned. And then we have the section name. This is within the code section. I don't think we have to worry about that. And then within the code section, it's whatever offset we are currently at. So however many bytes are currently in the code, that's where it goes. And we do context. Saraid says autocomplete. Ah, that would be it. It's not autocorrect, it's not autosuggest, it's autocomplete. Thank you, Saraid. Make me feel a little less crazy. And then we'd like to push into this object file this new symbol. Will this work? I have no clue. Okay, it apparently worked. Let's look at object dump and see what the hell it made. Hey look, a bunch of relocations. So we have a bunch of symbols. I'm pretty sure for local labels, you just have to compute the address and insert that or an offset to it. I mean, we can. We can also make the linker do it. Otherwise, you're going to get name collisions because they're supposed to be local labels. That's true. So if we had like sim type label, that'd be nice. So for local labels, you have to compute the addresses and insert that or an offset to it. That just means we'd have to solve those relocations ourselves, right? Because we don't know the offsets until we've generated all of the code. So really what we have to do is just keep track of these relocations like we already are doing, but then resolve them in the actual emission of the object file, I think. Or something like that. Or as part of the x86-64 deal. 421421, thank you so much for the follow. Sorry, it says, I suppose, yes. Yes, yes, yes. Because I don't really see another solution to that. As far as I'm concerned, at least. I don't believe. Why is there 2 .L7 relocations? Is that normal? That's very normal. There's also 3 relocations for GCD Euclid. Let's take a look at the source code. You'll notice that there are 1, 2, 3 invocations or calls to GCD Euclid, and there also happens to be 3 relocations. That's not a coincidence. These ifs and else generate a bunch of local labels, right? Which we can actually see if we take a look at the assembly. We can see these local labels, right? And we can see that, what are we looking at? Yeah, these local labels are referenced multiple times. For example, L7 is jump to from here, and then I'm sure as we keep going, L7 is jump to from here. So this jump to L7 and this jump to L7 both need relocated in the code, and both need a relocation entry. And you'll notice that the offset for them is different accordingly at 82 and 139, which if we take a look at the machine code, you can see that basically that seems really large. Am I crazy? Yeah, we're not seeing GCD Euclid, that's why. That's why. But yeah, so these local labels within GCD Euclid, I wonder if I would be smart enough with the symbols. No, it's the crazy GCD Euclid, this thing. Will you let me do that? It will. Here we go. Here you can see that we have the jumps that require the relocations with the 0 bytes. One at E9 and one at somewhere here. I guess we don't know which one of these is L7 necessarily, because we don't have any labels. Surprise, surprise. Okay, well, so for local labels, let's do this in the in here. I'm going to say for each symbol for the general object file within object.symbols, if symbol name okay. So if we compare these two strings and the first, I guess I don't want str compare, I just want mem compare. But symbol name might not be 2 bytes long. Well, this is not ideal. If strlen of symname is greater than 2 and the first 2 characters are dot and L, the first 2 bytes, then let's just print local label. And also I don't know what I'm doing, obviously, because this isn't smart at all. I'll get to why. Okay, but we are getting a bunch of local labels, so that's good. We're supposed to be looping over the relocations. The good part is that each relocation has a symbol. So I think we can do this. And then we can loop over relocation entries within the GObject file like this. Okay. Local label relocation. Okay. Which local label? Just get that out there as well. Perfect. Okay, so we have to go byte offset bytes into the byte buffer of the code section, or actually whatever section matches the relocation section, which I think we only have code relocations now. So that's just the code section. We have to go to sym byte offset bytes into the byte buffer of the code section. And then fill in the next bytes depending on the relocation type. Sure. I want to know the byte offset. Print me that bad boy. Okay, cool. Very cool. So at that byte offset, 113, 118, 130, 150, 163, 234, 305, 313. Currently, those are relocations. But if I went to, show me all the symbol bits. So if I go here, the byte offset, we actually have the byte offset of the label, right? And we know rip is just going, rip relative means that it's going to be relative, so we don't actually have to know rip in order to know things. We just have to know the instruction pointer, which we do. It's in rip, the register. So at the time of this relocation, the byte offset is this, plus some amount. Okay. At the time of relocation, not at the time of. So basically, if we find the symbol with this name, then its byte offset should actually contain the byte offset that we need to write at this byte offset. Hear me out. So honestly, because it's working, okay, I'm going to write a big old to-do. And then I'm actually going to do what's promised and write some, I'm going to assemble something for you guys. I feel bad. The whole, Range Bomber, thank you so much for the follow. But I feel bad. I haven't assembled anything. We're going to write some assembly. This might be bright. So instead of greatest common denominator, now, we will come back to this, I promise. Instead of greatest common denominator, let's try like, well, I don't know. Let's do while.int. Does that one work? It does not. And why doesn't it work? This is good. It says error, mcode reg to name unsupported instruction 24 move. So in mcode reg to name, I'm sure we just don't. Yeah, we don't handle anything actually. So that's interesting. So when we want to move the value of a register into memory, somewhere in memory, based on a symbol, a name, right? So in the case of imove, this is basically going to be very similar to reg to mem, because it's just going to be a relocation entry instead of a literal displacement. Anywho, we are going to end up switching on the size, and I'm going to have exit comments for all of these because this will get quite long. And there's just 4 sizes for now, and most of the time this is the form that it takes, where we have 16 fall through to R32 with an OX66 prefix to R32, and then R64 has a rex.w prefix plus the thing. And then R8 usually has its own encoding. Let's take a look. Move instruction in the Intel manual. reg to mem. So that's literally going to be this, 88R, because we want to move an 8-bit register into 8 bits in memory based on name, which is an offset from address register. In assembly, what would this look like? In assembly, this might look like, well, this, but the other way around, right? Instead of move condrip into racks, we're moving racks into condrip. We just need to do this the other way now. And instead of in assembler, in actual machine code, right? So for R8, it looks like 88/R is our encoding. /R, if we want to take a look at the beginning of chapter 3, volume 2, /R indicates that the mod RM byte of the instruction contains a register operand and an RM operand. So if we look at mod RM, our little table, we're going to need it. Yeah? Coolio. So this is going to be, what's R16? So move R16, it's OX89/R. Sounds familiar. Not 7. There we go. And then I guarantee you the 32-bit will just be this, and the 64-bit will just be this. Cool, huh? And for this little 16-bit prefix, we can just write something like that. And it's not fwrite anymore, it's actually mcode 1, because we would like to write 1 byte of machine code into the generic object file pointed to by the context. And we would like to write the 16-bit prefix. And actually, we can just write OX66 now with this new format. We don't need an address and stuff like that. We can just pass in a value, poggers. Now for the actual hard part, OX89/R, and also all the breaks, which I forgot to write. Oopsies. OX89/R for 32, and it's also 89/R for 64-bit, just with the rex.w prefix. I was right. Hallelujah. So you can see that these are all MR operand encoded, which means operand 1, the first one here, is in RM, and the second one is in reg, which means that our destination is in RM, and our source is in reg. Yeah? So we should be able to calculate our mod RM byte now. How do we do this? So first of all, we want to write the opcode, and then we want to write the mod RM byte, because it's followed by a mod RM byte. What is the mod RM byte? The mod RM byte has 3 fields, mod, reg, and RM. Reg and RM we already know. Reg is our source. RM is our dest. So let's just write this out a little bit. We're going to say mod equal, well, we don't know what mod equals yet, but we know that reg is equal to, oh man, I already forgot. MR encoding, reg, that's operand 2, source. Reg is equal to source. RM is equal to destination, yeah? And let's think about the mod. We have an address register and a name. The name specifies some offset from this address register, right? So this name is going to be a displacement off of the address register. So we can't just use the address register, aka a mod of 0. Isidiush says, hi, Lance. What's up? What's up, Isidiush? How's it going? Heretic Rush, thank you so much for the follow. What's up, Isidiush? It's so good to see you. You're always so positive. Hello, hello. Hi. So we have some offset by name, and because we don't know how big it is, we're just going to go with the biggest offset, which is a DISP32, which is a 32-bit offset, which is OB10, aka binary for 10, right? Or decimal 2. And this is going to be for register plus disp32. We want OB10. We want our source reg bits, right? These ones we want in here. And then we want the destination. Well, we don't have a destination. We have an address, by the way. Because we're moving into memory here. So address is going to be the reg bits of address register. Thank you. Here's a piece of pizza or a Dorito. That's a Dorito, isn't it? we got a Dorito from Isidiush. Thank you for the Dorito. I'll lick my fingers afterwards too. I'll look you in the eyes. And then as we know, register, the second parameter is source reg bits and then address reg bits. Gordo Kagwai, thank you so much for the follow. So this is our mod.rm byte, yeah? And then we just write that. And the interesting thing is that I think this might be the same for all of these. Maybe even all of them, period, for like all of the instructions encoded. I'll just leave it in move for now, but we may be able to simplify this even further. As for the rexness, we need to calculate the rex byte. And to do that, oh, also I forgot to do something, so that's good. This reminded me. We need to do the thing where we emit the rex byte optionally, not to extend it to 64 bits, aka set the rex.w bit, but we need to set the rex.b and rex.r bits based on these, because they extend. Let's take a look at what they extend. Rex prefixes. Rex prefixes. We'll get there, don't worry. Here it is. So the field name for R, the second bit, the third bit at bit position 2, is an extension of the RM reg field, and then B is an extension of the R/M field. So this is reg, and this is RM. And as we know, we have this is in reg, our source, and our address is in RM. What does that mean? That means that our rex byte needs the reg bit's top, right? The top bit. It's not going to have W set. It's not going to have X set. But it will have possibly these two set if either of them are set. This will make sense soon. So if the source top bit is set or the address top bit is set, then we can't encode that in just 3 bits. We need 4 bits. So we need this extra prefix byte to encode these bits. And to do that, the R field is an extension of the reg field. And the reg field is our source. And this is our address. And then we just need to write this into the actual file as such. Isidiush says, ooh, what are we doing here? We're writing assembler. So we're actually using the Intel x86-64 manual and looking at the move instruction to implement for the intercept compiler the assembler portion for generating machine code for the move instruction in this specific register to name form. Hopefully that makes sense. Any questions? I'm open. And we can't write this here. I put this in the wrong spot, so silly me. This needs to go here, not here, here, because it needs to go directly before the opcode if it is present, and it needs to go both for the R16 and R32, whereas for the 64-bit, which is why I got reminded of this, it's always included. So there will always be 3 bytes that we're writing for 64-bit, which is going to be OX89 mod RM and our rex first. But our rex byte will be the same thing as here, where the top bits may be set to encode the register, but the W will be set to encode it as 64 bits instead of 32. How poggers is that? And then, lonely guy up here, we're going to have a very similar thing to the 32-bit version, except OX88 is what's going to happen for this guy, because we're moving a register 8 to RM8. Perfect. And then for all of these, what I didn't mention is that there's actually a displacement that we need to do. Right? The disp's 32, remember that? So we need to actually write this in the following way, I'd say. Where we write some zeros after the mod RM byte. And then to do generate relocation. So this is where the actual relocation needs to be generated so that we will actually be able to have this name, right, be associated with this offset. Coolness. Unhandled register and reg bits RIP. Okay, this is another interesting case. RIP relative addressing has a custom. You can't actually encode in that little table we were looking at. You can't actually encode RIP. You can't encode the instruction pointer. Also, I'm scrolling in the wrong place. Here. There's nowhere to actually encode instruction pointer. So how do you actually do RIP relative addressing? Well, luckily, the Intel manual has just the thing for you in that it has a whole section. First time chat from Range Bomber, you followed earlier, with the little evil Goomba. Resvon says, you seem really cool and smart. Oh, thank you. Thank you, Resvon. I appreciate it. I'm not, I promise. I'm just a regular little boy. Okay, so as you can see, for RIP relative addressing, there's a custom mod of 00 and things like that, where the RM is actually set to 101, which would normally not really mean anything. That actually is the specific none portion. So yeah, we have to do this specific handling, which means that this mod RM, let's just calculate both. And we'll do the RIP relative mod RM as well. Right? But because it's RIP relative, we don't actually need the address reg bits. So we're going to have to do... I see, that's the problem. We can't call reg bits on RIP. Let's just move all this into the... into each one. I don't think that's really a problem. I'm not worried about code duplication right now. If I was, there's a lot more things I'd be focused on. And you'll see why this actually matters at all very soon. Okay. And obviously we have to get the rex after that. Okay. So for RIP relative, we are able to detect that because address register in our custom enum is going to be equal to reg rip. Yeah. So what we're actually going to emit, we'll also have to generate a RIP relative relocation. And basically, instead of doing this whole thing, we are going to need the source register bits, as far as I know. Generate rip relative relocation, that's going to be near the bottom. Our mod rm, mod is going to be equal to 0. Rip relative mod rm. Right. Cool. Mod 0. Reg is 101. Nope, rm is 101. And reg is the thing we care about. Still. Which is why we still need these. So now we have our mod rm byte, which is going to equal mod rm byte, but ob00 source reg bits and ob101. And then we're going to have something very similar to this. Following, we're just going to write our displacement, following our bits, our bytes, which is going to be 2 of them, which is going to be OX88, followed by mod rm. And then possibly there's going to be a rex prefix if source reg bits is a thing. Hopefully that works. This won't work because it's only for the 8-bit version, but you know, I can try. A man can dream. Failed. What failed? Source reg bits. What? What happened? Undeclared. Did you mean source register? Where did I do that? Okay, tell me the line. 1637. Ah, yes, that would be difficult. There we go. We're still getting unhandled register and reg bits rip, and the reason for that is because this is only handled in R8. We also need to handle this for 32-bit, in which case it's going to be OX89, right? OX89/R, followed by the displacement for the mod rm byte, and the optional rex prefix. And then we're going to have here the 64-bit version, in which case the rex bit will always happen. We can kind of just bake it in here. And like this. And then it's actually going to set rex.w as well. Perfect. Now we're back to unsupported instruction 24. What? Mcode reg to name, isn't that where we are? Mcode reg to name, case I move, value 24, switch on size, R8, R16, R32, break, break, break. Oh, there's no break. That'd be an issue. Sorry for that Squidward, I just had to do it. Norin and Ujidu, thank you so much for the follows, I appreciate it. Hey look, we're no longer failing. So let's take a look at what we're actually outputting. Okay. What did I just do? I did a move. So I'm going to need to disassemble main, let's say. And there should be a move into memory somewhere, apparently. No, not here. Where else would it be? Why did you need me to Why did you need me to encode this instruction if you didn't even care? Why have they done such things? No, it's got to be here somewhere. I'm sweating. Oh, hey, I found it. Because it's all messy. rex.w is set even though it shouldn't be. Oh yeah, for rip relative 64-bit moves, the rex.w never needs to be set. I remember that now. Okay, now it says rex. So we're encoding rex when we don't need to. And it's saying move AL into rip. What's the actual, can we look at the assembly and see what we're trying to do? We're trying to move rax into rip. So we should have rex.w set. So why is this incorrect? What's going on here? Am I extending, did I get these in the wrong order? I may have got these in the wrong order. I do that often. No, okay, that didn't work either. So we still got some issues here. We have rex.w move al. Why aren't we moving ax? Right, why aren't we moving ax? We have rex. Oh, we're writing the wrong opcode. OX88 is different than OX89, as it turns out. Okay, it's working now. So, as you can see, we can now move rax offset by rip, and then we now have to generate relocations, rip relative and not. And I'm not going to make myself do this. I have done this. I have done this before, and I don't need to do it again. Generate rip relative. This is just a regular relocation that I'm housing here. I should probably have the same comment. To Leah. Okay, not the same comment then. Was I here? No, this is case I move. Encode reg to name. I was here. Okay. Generate relocation. Basically, there's a 4-byte displacement. It's right here. So before we write it, create a relocation and reference this thing. Cool, huh? And we need to do that a bunch of times. Every time we generate a regular relocation, I'd like to instead do this. So if I do this, can I get away like that? And this is just creating a basic symbol with the name that we are accessing, the section, the code section name, which is always going to be .text, right? This doesn't really, not really important for our use case. And then we have the relocation type and the byte offset, which is the current offset into the code section's data in bytes. Hopefully that makes sense. That's why I'm not really focusing on writing this code myself, because it's all very boilerplatey and should probably be a function or something like that. But in C, it makes it difficult to do that. Now we have a bunch of rip relative relocations that we need to do. And these work as such. These ones assert that we need a code section, that's fine. But it's the same byte offset name, section name. This is all the same, but you see the type is where it differs in that dips32 PC rel. instead of PCRel means program counter relative, and that is what we need. So let's go to our next rip relative location and pop that in there, and make sure that you emit the opcode and up to the mod rm byte before you create the relocation entry, otherwise you're going to have a bad time. Shouldn't there be another? This is not correct. Here we go. Lens, I have a question. Will you ever make small and short educational YouTube videos where you LA5 things that are complex such as this? I think that'd be awesome. I've had better luck just answering people's questions than doing YouTube videos because I just deal with like corruption and project files go bad and I just lose motivation. It's hard for me to stay motivated on video projects. And I think I care way too much, which is why streaming kind of gets rid of that for me, because I can't care all the time. I didn't want to disassemble. I wanted to -X to see the relocations. Well, cool. Okay. We have relocations now. Hopefully we can still we have undefined reference to L1, L3, L2, and L1. Undefined reference. Even though we're defining them. But we're not defining them like main. So I wonder if I have to treat them like a function. Again, this is the whole external thing, or function thing. But yeah, Isidayush, I would love to make more educational, like quick videos that can be more digestible, right? But at the same time, it's really difficult for me. I don't know why. But yeah, I would love to. I've tried to multiple times before. It just hasn't gone well. Either video files or being corrupt or render not working, just getting like flashing in the output or just things like recordings not being saved or the computer crashing while recording and then you lose everything. It's like there's so much that has happened. I've just been so unlucky and it's not fun. There we go. You can see now it compiles, which is good. And hopefully it runs. It returns 0. What are we compiling? While? I'm not sure it's working then. Because I don't think it should return 0. I think we should be printing some stuff out. So can you actually disassemble what I'm looking at then? So you can see main, and it's now broken into labels, so that's funny. You can see main. We now define all these as well. And then we have conned references. This is good. Then we call putchar after moving into ECX. Everything should be fine here. I'm not sure why this is being an issue. Jump 1550, which is L1. It looks like the jumps are being filled in properly. So why would you not print things out when you run? Here, we'll do some Emacs GDB. Why not? Yeah. This is fun. And then can you GDB disassembly, display disassembly buffer. Thank you. Break on main. Run. Okay. Registers. Okay. Now, step through. Why do you not work? Is it used as 6 screens? I mean, yeah. I'm using this one right here mainly. I'm continually stepping through instructions, making sure nothing crazy happens. So we're about to return. And that was it. We've returned. We're out. So if I run again, what's actually happening? Why did we jump? We have a direct jump to L1. So when we jump to L1, we're now here at L1 or whatever, right? So we jump to L1. It's literally just the next instruction. We don't go anywhere. That's why it's weird. And we jump to L2. And okay, so we're doing like tail jumps, but that at the end, we should jump to L1 again. So let's keep going and wonder what goes wrong. So we move some value into racks. We're moving condition into racks. We test it. We jump if it's equal. And now we are somewhere else. We're about to return. So we jump to L3 real quick. We jump to L3 right away. Why did we do that? Let's try this again. So what's in racks? We never get to see there. Okay. So we're about to move the value of condition into racks. So now racks has 0. So the value of cond is 0. Is that correct? I feel like that's not correct. The value of cond should be something, shouldn't it be? Shouldn't it not be 0? We're looking at while. Yeah, cond should be 10. Why are we not emitting cond as 10? Interesting. So maybe it has to do with the initialization. So can I do -x? Okay, not what I wanted to do. There we go. So we've conned, whatever. This is a bug with the terminal. I've talked about it before. So cond, we know it's offset. It's at 1b8 within the data section. Is that right? Why is it at 1b8? What is 1b8? Why is that significant? That seems kind of wrong. 1b8. Where would that be being set from? This is a symbol in COFF. So this would be the symbol byte offset, right? Create symbol for var name. Okay, so if it equals a IR literal integer, we do the thing here. We create a static with var name in .data. Byte offset equals data byte size. What have I written to it already? Why is it so large? Section init data. Get section by name sections.data. And I'm creating it up here. So we're creating it with 0. We set its name, we set it to writable. 1b8 is bigger than the size of the data section, it seems. Yeah, that's why I'm a little saddened. So this is in section 012. Is that correct? That seems wrong. If .text is section 1, how's that section 2? That doesn't make any sense. Oh, that does make sense, actually, because then .data would be section 2. And then this is code, 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 code. And then put char is the special case because it's external. Okay, so that's fine. I solved that. 1b8. The byte offset. Is it really that big here? Good old printf debugging. Give me that number, baby. Show me the money. Byte offset 0. Okay. Well, then why'd you put not 0 in there? Why'd you put not 0 in there? Why'd you go and do that? So assuming that this isn't the problem then, where would the problem lie? We have out.object, out.o. I wonder if it has to do with a specificity, because here we have 0.data. Everything's fine here. Everything's fine here. So I wonder if I could compile this ELF file. Not out.object, out.o. Well, that kind of worked. I'm not really sure what went wrong or how. I'm clearly not printing the right value, right? But I'm not printing the wrong one, so we are printing something. We're calling putchar. So we're getting closer to a correct program. And we wrote some assembly. We did write that move reg to name. And it's in use. Range Bomber says progress. Exactly. Exactly. That's what I like to see. So we emit this static. Maybe it has to do with the COFF specifically symbol. So when we're emitting COFF symbols, we truncate the name for now. Bad, bad, yes. Section data offset plus equals size. I is equal to index. Okay. What are we doing here? I don't think this is correct. I think that should just be byte offset. Maybe I'm crazy. Why were we adding... That was the file offset. That was the absolute file offset. And I don't think that's what goes there. We do have now 0 in cond. And we're not doing crazy things when we're relocating. So this may actually be correct. Section 2, data. Now it's 8. Okay. Out.object. It never quite stopped. But we are now printing things out, so that may be some sort of progress. And can we try it? Okay, nice. So we're getting somewhere, right? We're getting somewhere. T-Lasts, thank you so much for the follow. Also, I missed a chat. Vegan, 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 vegan. Hey, Beast, I'm hoping the dev is doing good. Thank you so much, vegan. Did you try turning it off and on again? Yeah, maybe I should try that. Byte offset within file of this symbol. Well, if that's the case, it would be, what's section data offset? What is that? Section data offset. So we're looping over sections, and section data, so this is after all of the section data offset is the size of all of the sections put together. Data start is where the section data starts. So this is the file offset at the end of the data, of the section data. Is this necessarily where this will go? And also, why is this a byte offset within file? COFF storage class stat. The offset of the symbol within the section. If the value field is 0, then the symbol represents a section name. Okay. This is symbol entries, yeah. Symbol table. Special values, yes. Meaning of n value. cstat for .data and .bss. Offset into section. Well, okay. Then that would be this. But if that's true, what's going wrong here then? This does look right. Zarias says eyes. What's up, Zarias? How's it going? We got the big eyes. Big eyes. So what's going on? Why are we having such a hard time? We want to use GCC and then not have it print infinite things out. Does it start with printing the right things out? That'd be at least one thing that's good, right? If it starts printing the right things out, then that means it's just the end that isn't working. Apparently it went for a lot longer than I thought. Oh man, just that little bit, huh? Just that little bit. Really churning through those. I really got to turn off optimizations. Jeez. Wish it didn't run so fast, so it would print less. Oh my god. At some point, we should hit the command we ran. Okay. And it's not even printing the right value. It's printing U. U is OX55, which doesn't make any sense because that's 85. So we're just kind of having a random value be printed at the beginning. Whereas we should be starting with 9 as far as I'm concerned. We should be starting with 57, right? I think we're gonna have to use GDB again. I don't know what else to do. We're gonna take a look at it. We're gonna run a.exe. We're gonna break on main. We're gonna make sure to display disassembly. And we should be good to go. Show me my registers as well. So overall, what this beginning thing is doing, we should move the value of cond into racks, which should give us 10 in racks. We have the number some insanely crazy large number in racks. That's not correct. Zarya says, good, what are we doing right now? We're writing assembler. So basically intercept has been outputting assembly for a while, right, in code.s. And now not only does it emit assembly, we're making it so it emits out.o and out.object, which is an ELF 64-bit and an COFF 64-bit object file, which means that you can directly just use this to link with other programs instead of the assembly. That also involves generating machine code from instructions ourselves. Ironically, that's the easy part. The hard part is all the object file stuff and symbol scenarios. So we get some crazy number in racks. So cond effectively then is wrong. Cond is wrong. Why is cond wrong? I don't know. I don't know why cond is wrong. Most likely, it's not being initialized properly when it's being written. So when do we write it to the .data section? Right? So we add this symbol to the .data section. Oh, right here, sec write n. And then we have section init data where we write var init im type size of var type. I don't think that's right. Let's just do some tests. So I think what we're going to have to do so effectively we're getting the first this many bytes. So we have oxff, which is 1 byte. To the left that many bytes minus oxff, and that should get us the actual number we need to AND this thing with. Okay, let me think about that. So I want this many bytes set. I think I can just do this with 1. And then multiply this by 8. Okay, so for example, if I want 4 bytes set, then what I'm going to do is multiply that by 8 to get the amount of bits. And then I'm going to shift left by, or shift left 1 by that amount. And then I'm going to minus 1 from that. Minus 1 isn't a function. It is in Lisp. And that gets me oxFFFFFFF, aka 4 bytes set mask. Wonderful. Print that for me. I'm curious to see what it is. It says 0. Well, that's unfortunate. Isidish says, good old print, the greatest cross-language debugger. I mean, it's true. Well, if that doesn't work, why is var init immediate 0? And what have we done to cause this? Can we just print var init immediate itself? I'm pretty sure it's 10. See, we have 10 and then 0. So this is an issue in how we actually write the data. And it's going to require a switch on the size of the type. Well, no, I think we may just have to do this. If we get byte representation is basically a byte pointer to this value. And what I want to do is make it so that each of these bytes starting at 0. Is this going to work? I don't know if this is going to work. I don't feel like this is going to work. Because I don't feel like me taking byte representation here would really matter. Anybody remember what I was looking for? Cond is 0. Didn't I already have that? Why is this a problem? Oh, because it's actual value in data. What is con's offset? It's in the dot data, which is at offset 8C. Also, dot text has file offset 8C, and so does BSS. That doesn't look right. Would help to do the proper file. And it says what? OX8C? Supposedly OX8C into the file. A, B, C. This guy? D, E, E, F. Oh no. This guy. C0. This doesn't look right. So we're supposed to have 10, which should be an A in hex, right? But there's not an A here in hex. There's, especially not at offset 8C. Is there an A kind of anywhere around here? Followed by a bunch of zeros? There should be A, 0, and then followed by 7 0 bytes. Is it used as grep it? I mean, that's it's doable. I don't know if it'd make it easier. 1, 2, 3, 4. That's not correct. See, it's similar to this. It's going to be very similar to this, but with 8 bytes instead of 4. Because condition should be an integer, which is going to be 8 bytes. Here it is. So is the file offset of .data incorrect? That should be set by generic object. So the section, we loop over each section. This is for the symbol table. We loop over each section for the section header table. And then we put its offset So this is where we're writing the section headers. So where is the offset being set here? Am I not setting it? That would be embarrassing. What's it called? Section footer. That's what it is. Data offset. But then we're not incrementing data offset. Why are we not incrementing data offset? That's a little interesting, ain't it? We should be doing data offset plus equals size every time. Because this is where the section data is ending up as an offset within the file. Okay, the file offsets are different now. They actually look correct, so that's good. Hey, that's much closer. That's much closer to what we want, ain't it? That's, at least it's consistent. Hey. we have now COFF and ELF producing the same wrong output. This is good. Izzyu says progress. Yes, exactly. Range Bomber, new record. Exactly. I like it. I like it. So, what are these cases really? So there's a few things to fix, I'd say. Two of them are kind of COFF fix-ups, which we're going to commit right now. Oh yeah, I forgot I did that little type checker fix earlier. I should push that to the main branch, really. COFF bug fixes. 1, static symbols and value member holds a byte offset within section, not a byte offset within the file, as far as I know. 2, we weren't ever incrementing data offset. A huge deal. Lol. Okay, so we fixed those two little things. Immediate to reg, we're missing a rex prefix, so I added that in x86-64. Add missing rex prefix. Add potentially missing rex prefix to move immediate to reg form. Oh, that's right. And then I also did some fixes this morning for the MSWin calling convention. Oh, that's right. I did do that. I did do that. Okay. Okay, good, good, good. We're making progress. Why does it do this thing that it does? So what value are we actually getting now in GDB? Let's do our crazy GDB thing. Oh, a.exe, no such file or directory. Phooey. And let's do the object. And if I ran a.exe, it does that. If I gdb a.exe, weird, it says the same thing. Oh, maybe I'm running, that's what's happening. Whoops, I did not mean to do this. I'm running it not from the proper place. There we go. I'd like to set a breakpoint at main. I would like to make sure to display the disassembly. Show me the registers. Thank you. And run. And now step in just like we did before until we get to that move. Hey, look, OXA. We now have 10 in racks like we're supposed to. So now we should end up with 9 in racks. Let's hope we do. Because we should subtract 1. Hey, we have 9 in racks. Look at us. And then we should move that back into condition. And then we load it back again. Okay, so now we have 9 in racks. Now we add racks to RCX. Oh wait, we've done something wrong. There's an incorrect encoding. We're not doing a proper encoding somewhere. Yeah. What? Oh, because of the local. We're doing something wrong. This doesn't make any sense. This is wrong. Because it doesn't make sense to move OX30 into EAX, aka racks, right? Because its sign extends 32-bit immediates to 64. So we have a 64-bit OX30 in racks, and then we immediately overwrite it with the load of another variable. That doesn't make any sense to me. This should be into CX as far as I know. And if we take a look at not the disassembly here, but code.s, then we will be able to see that in fact we are moving 1 into OX30, aka 48, into EAX, and then we're moving contrib into RCX. So this operand right here is being encoded improperly because we're moving into RAX. So this is in move name to reg. That isn't the one we just wrote, is it? No, it's not. So move name to reg has Leah already, and it has move. So when we move, we're moving 64-bit, right? Name to reg. Yeah, we're doing 64-bit. And the destination is in the 2nd bit here. I don't think that's proper because we take a look, what's the register encoding of that? So name to reg is one of these, which means it's actually RM encoding, which means we have register is the written and RM is the read. So it's kind of backwards from the other way we were thinking about it earlier. Jeff, thank you so much for the follow. So what this means is that because these operands are swapped, then our destination, where it's being written to, is actually in reg, and register is actually extended by the rex prefix R field and not the B field. So this is actually in the wrong place. Ain't it crazy how little things like that happen? So do I do that anywhere else for RIP relative addressing? RIP relative addressing. So what I'd like to check, see, this one is correct. The destination goes first. Destination for, this one's incorrect. That's a dangerous move right there. This one's incorrect. That one's proper, proper, proper. Okay. All the ones we wrote today, at least, are good. Okay. Now we can just look at the disassembly and check that it's RCX. It's not. Damn it. Why wouldn't it be RCX? Mod RM. Oh my god. Chat. What are they feeding me? It must be like some non-nutritious sludge. Why am I not passing in the bits for the register that I need to encode to the mod RM byte? Of course it's racks. Of course the register isn't being encoded. I'm passing in 0. Christ. Oh yeah, look, here too. How did I screw that one up, huh? You're like, yeah, just ignore it. Pass in 0. That'll help. Oh my god, I've done it so much. Again, at least the ones we wrote today are fine. Is it you not like this? Please be an RCX. Okay, we're moving into RCX now. We have fixed our assembler. That's a big bug. Oh, I should actually test that we fixed it. Oh, bog champ! Boggers. Look at this, chat. 9876 543 210. That's what we want to see. Oh, that's what we want to see, chat. Ooh, that was rough. You see all those bugs we just fixed? I have so many things I want to say, but I can't right now. I want to make jokes, but they're probably not good jokes. Yeah, let's just fix this major glaring issue where I just failed to encode the destination register because, I'd rather pass 0. What a failure. What a failure. Okay, then the thing we wrote today, then the MS Win calling convention, and then the relocations. Okay. At this rate, we're gonna see Lens rewrite the moon landing soon. Major glaring issue. Glaring issue with regarding discard of reg bits. We're gonna push those to the moon and back. PogChamp. Okay, well, while now works. And we have one more instruction. Maybe we go back to this local label thing now. So, do we actually have the symbol with this name? We don't. So let's find the symbol with this name. Do I have a little helper for that? No. I have get section by name, but not get symbol by name. Which probably should be a thing. Probably should be a thing. This is going to be the label symbol. And we're going to say for each symbol, S in symbols, if string compare of name equals name. Label sim equals s break. If not label sim, internal compiler error, and say could not find local label referenced by relocation. And then pass in the symbol name. Now that we have the label symbol, I would like to say disp32 equals this thing, which is going to be the label sim byte offset. Legendary. So you can see that at byte offset 12, within the machine code, we jump to L1, which is at byte offset 16. Right? Right. And then this label, where does this label actually refer to? The label refers to the instruction pointer. The label refers to the instruction pointer at the time that the label is created. Is it used as live on Twitch? Yep, moon landing live on Twitch, coming soon. I'm gonna build a rocket. So ideally, we go to this byte offset and we write this into the 4 bytes. Bytes at offset equal what are the bytes at offset? So I want a uint8t pointer iterator, which is going to equal to object sections. I want the code section from this object file. And from this code section, I want the bytes data. And then I want to say plus, not this byte offset, the symbol byte offset, because there should be 4 zeros here. So for int I equals 0, I is less than 4, plus plus I, could you please print for me a byte, just some number, followed by a thing, and this number is going to be whatever is at it. Cool, we have a bunch of zeros. That's exactly what we want to see. Now, into this place at iterator, we want to write, we can call that destination, I think. We want to write our source. And our source is going to be equal to this thing. That's a size t, though. So I need a uint32t. And it might be an int32t, actually. So this is going to be our dips32 or whatever. And then this is going to be and disp32. And what I would like to do is write to pointer dest pointer source. And then for now, could you please print me out what we have written? Okay, we've written 4 16s, 4 140s, 4 37s, and 4 16s. That's not exactly what we want, right? More ideally, I'm just gonna name these consistently. It's bothering me a little bit. So we have a destination iterator and a source iterator. Then we want to cast. Cool. And from here, we also want to increase both of these iterators each time we write. The tricky part is we don't want to technically do this until after we print it, so we are going to have to move that. But you can see now we're writing the little endian version of this thing. To do, handle endianness. And if you don't know what endianness is, obviously if a number is 4 bytes, right? You have like 4 boxes that may be filled with a value, 0 through 255, right? So you have your 4 bytes. So how would you represent the number 40? You could put 40 here in this byte and then have the rest be 0. Or you could have 40 in this byte and have the rest be 0. And the lowest address is here on the left. There's no difference in these two other than the fact that they're different, right? They represent the same value just in a different way. This is called little endian because the least significant digits come first, which is the opposite of how we write numbers as humans. Because if we write 1010 like this, then the 1 here represents the largest digit, right? Not the smallest. Little endian, which is how x86 64 CPUs are, represents the smallest digit first. So it would be as if we wrote this number 0101, and this is still 1010. It's just written the other way, right? And each digit happens to be a 2 exponentiated to the 8th power number, right? Which can be between negative 128 and positive 127, or 0 and 255, depending on how you look at it. So that's the difference between endianness, and why we need to handle that is because we're writing multiple bytes of an integer to a file or to memory, and we need to actually know which order things are in. Whew. How would we represent 69420? That's actually a good question. So in 4 boxes, right? You can't, because the maximum 32-bit value is going to be 1 to the left 32, right? Oh, I guess we should be able to do that. I was thinking of 16 bits, never mind. So to do that, all we have to do is take this value, 69420, and then we have to actually AND it. I don't know if we have the AND. Yeah, I don't think we have AND. We might have to use Python or something. Yeah, let's use Python. Why not? So we have 69420, right? The bog, fun. And to represent it in bits, what we have to do is basically convert it into these digits and then store the values of those digits. So to convert the base of a number, I'm pretty sure we have to multiply by the base and then modulo the base, and that's what goes in here. So in here, actually, it's reversed. Basically, we should be able to do... Can we do that? We can. So we can get the bottom byte of this, right? And it's 44. So we'd write 44 here. And then we can also get the second most byte, which is 3840. That doesn't make sense. That's not the byte. That's the byte, 15. And basically, you do something like this to actually get the values that you need. And to do that without abusing another programming language to actually do it for you, you have to do some base conversion math, where you'd take 69420 and multiply it by the maximum number that you can store in here. Right? Like the base of the number that you're storing. So because it's 0 through 255, that'd be 256. And then that would get you some number, right? That would get you some number. Let's call it x. And then you would do x modulo 256. I think you would actually take the first digit and then use that. Or you'd divide it and then... That's right, I'm thinking of floating point too much. You would just divide it and get the modulo. And then you would get x, and then you'd say x over 256 equals x prime or whatever. And then you'd say x prime modulo 256, right? You do something like this. And then that would get you each digit, and then you could just store that here as you go. But this would be in reverse order because you'll get the largest first, as far as I know. So you'd have to then reverse it. Hopefully that makes sense. That's the mathematical way to do it, because you'd have to convert from the decimal digits to the 0 through 255 digits, right? The 4-digit, 0 through 255. But if you just do it on a computer, that all is kind of, it just happens for you. So you can use like Python. Thank you so much for the follow. What a name. Okay, so we now write those things. From here, we should remove the label symbol. Not remove the label symbol. That's for here. Remove all local label symbols. Maybe we should have a way to just set them as like not important. So maybe we should have a GObject sim type ignore. Right? Ignored symbols are never emitted into final object files. It may be used for data transfer, but may be used for anything by a particular backend, by a particular user. Sure. To do call Python when using big numbers. I mean, honestly, that's not a bad way to do it. There are worse ways. Remove all local label symbols. So instead of doing that, could we just set them to ignore? Cool. So let's do that. And then all these relocations we will have to remove. So maybe I should store indices to remove and then go through and remove them. Or I could do the same thing for relocations. and have a relocation type. Have like relock ignore. Ignore these relocation entries. And then for each relocation that we end up handling, we can set its type to ignore. Unhandled relocation type in generic object.c. There sure is. If relic type equals relic ignore, continue. We still have to add it down here. Otherwise I'll get the same error. Actually, I won't because we'll never get there, so we're fine. And now we have the ELF file format complaining, as you can see. That kind of worked well. Again, we don't need that. We just need to do this. Respect the ignorance. Cool. I haven't fixed it yet, but we are getting somewhere. So I think there's a leftover print somewhere. 10-0. Where's that from? Where could this possibly be? Where are we printing 10? Not in generic object.c. Here it is. Jeez. Okay. That's right. We now fixed that. Unrecognized storage class 0 for .text symbol .l0. Well, you were supposed to ignore it. Yeah, that's gonna cause a whole bunch of issues. I don't know if I like this ignore thing. I think we should just remove them. Because I don't think it makes sense to, like, keep them around. I mean, it is difficult, but I don't think that's any reason to be like, oh, we shouldn't do it. What happened? Oh, all the ignore stuff now. So we're getting rid of the ignore stuff because in favor, instead of ignoring things, what we're going to do instead of ignoring things is remove them, which simply means that we can take this little ditty here, turn it into a pointer, use the data and index of this. Can I use I? No. Okay. So now we have the index of each one, and we can keep track of a vector of size t or whatever. And this is going to be relocations to remove. OmniStack, thank you so much for the follow. I appreciate it. And then symbols to remove, yeah? The interesting thing is these aren't sorted, so removing them is going to be difficult if they're by index. What else could I save? I could save by name and say remove these symbols with this name. I think that's reasonable. And relocations will be in order, so we don't have to worry about that. And now, so if Sterlin, so if we get to here, that means that we have removed it, which means symbols to remove. We would like to push the, what have I done? What symbol did we just remove? Symbol name. The local symbol, sure. And then we also removed this relocation at index, and we'd like to remove that. Okay. Okay. For each char pointer, name and symbols to remove. If sure compare. Yeah, this isn't going to be ideal, but it's fine. Then for each symbol in symbols, find what is the actual vector delete or remove? Is there actually like a remove at index? So we have remove at index and remove element. So I think remove index is what we're going to have to keep. And we're going to need a g-object symbol pointer sim object.symbols plus index. And then if this symbol name matches the symbol to remove, why are you mad? Oh yeah. And then what we can do is say size t sim to remove index equals -1. If sim to remove index equals -1, continue. And this is going to be sim to remove index equals index break. Okay. And then if we can, we would like to remove sim to remove index from object.symbols. And then we will, oh, excuse me, we will not be looping over anything. So no iterator invalidation. Cool. For each reverse, size t index in relocations to remove. We vector remove index from object.relocations index. It's relax, relax, relax. Oh, and then this is going to be a pointer, so I have to do that. Well, it did work. We still have .L0. But it did work. Why do we still have .L0? Can you give me a -x then? So we got rid of almost all of them. Can we look at the actual jumps and see if they're correct? Call 7a. So how many of these in the code? If I remember correctly, they just jump to the next one. Everything except for L3. The one before L3 should jump to 9c. That seems wrong. Seven A, 5, 9, 4A. So L0 starts at Leah, L1 starts at moveCond Rax, and L2 starts at moveCond Rax followed by move1 ECX. L3 is then followed by move0 EAX. So move0 EAX, this is L3. So at the beginning, we should have a jump to 8C. Jump if 0, a JZ, right? Which interestingly, we have JE. This may be incorrect. But then that says AC. AC is outside of this function. So I'm a little worried that this is incorrect. So I think I haven't done the relocations properly. So can I think about what I'm writing here? The displacement is from the instruction pointer. So the label instruction pointer offset into this section is this, but we need to get the difference so we have like some bytes. Let's just say we have bytes like this. Each of these is a byte. There's 16 of them. At 7, or at, what is this, 0, 1, 2, 3, we have .L3. And then here, we have a relocation of .L3 that mentions it. So to jump to the proper place from here, we need to add the size of the displacement, aka 32. So we need to add 4 because we need to actually be here, and then we need to subtract, right? Yeah. So the rip is actually, yeah. So rip is actually here. And if we want to jump to L3, then it's going to have to be -1, 2, 3, 4, 5, 6, 7, 8. It's going to have to be -8 stored here. So to get -8 stored there, we have to do the value of L3, which is 3, minus the offset where we're storing this plus 4, which is going to be 0, 1, 2, 3, 4, 5, 6, 7, which is going to be 11. 11 minus 3 is 8. Okay. So this byte offset, we're actually going to be subtracting 4 plus 4 is equal to size of displacement. 4 plus, and then this is going to be the sim byte offset. What's the issue? Implicit conversion loses integer precision. So we want this to be an int32t. We want this to be an int32t. Why are you not cooperating? Okay, let's think about this. Jump 10. Well, that looks better. That looks much better. So there's a Leah, then a jump, and then a new thing. There's a Leah, then a jump, then L1. And when we jump to L1 at the end, we jump into a move racks test. Into a move racks test. So we jump 10. That works. Okay, can we now generate a.exe from this? Well, we can, first of all. Is this working? Chrono Shwe, thank you so much for the follow. Countoren, thank you. Hi there. What is going on? Thank you so much for tuning in. Hello, hello. Yes, you, Countoren. 145050. Cool, we're now doing our own little linking. We're doing a little bit of linking, right? We're writing these little values in, and they actually work. Poggers. That is a PogChamp. What are you building? Right now, I am fixing up and writing an assembler that for x86-64, for my language that I've created called Intercept, particularly, I'm making it so that you can just run the compiler, intc, fed some Intercept source code, and then it will generate out.o and out.object, which are both COFF and ELF object files, which can then be linked or inspected or whatever by in all sorts of manners. But it requires relocation records, symbol tables, sections, and doing all this and knowing what you're doing. But we fixed it, so we're now doing our own local label lowering, or whatever you want to call this. So what we've just done is, you know how in assembly, like even if you go to Godbolt, you know all these .L0, .L1, .L2? You may know already .L anything means it is a local label. And generally, it means it is a local label, right? So for example, within this function main, for this while example, here's the code, right? This is my language intercept. You can see that we have a condition variable, and while it's non-zero, we assign it to itself -1, and then we print it added to 48, which is the ASCII 0 character. We could technically also do this, but I don't think that's very nice for the ASCII 0 character. I think we should just wait until we actually have characters. Crashy says the file extension of your language is .int. That's really cool. Yes, it is. Intercept.int. I figured it'd be good. And the compiler is called intc. Range Bomber says cool indeed. Thank you. But yeah, and you can see we have external function declarations for things like linking with libc. And when we generate the object file, as you can see, we generate an external symbol, but we also generate a relocations anytime we need to actually use that symbol, which means that the linker can know what to do. Okay, what have I done? Oh yeah, that's what I was talking about. So in code.s, these local labels, right? They're used for jumping around within this function. They're not used for function calls, right? You'll never see a call followed by a local label. And if you do, it's some horrible, horrible stuff, I promise. You'll never see a call followed by a local label, yeah? What you will see is a jump followed by a local label, like here. And in this case, it just jumps to the next one, right? It does nothing. But if we take a look down here, we jump to L1, and that is our while loop. It jumps back up to L1, and then it tests our condition, and then if it's 0, goes to L3, and that's our exit. Otherwise, we keep looping over and over and over and over and over and over. Vegan says int can be integer or intellect. That's true. Crashy, thank you so much for the follow. I appreciate it. Well, I had to do a little ASCII art, but I did end up figuring that out. Note 4 equals size of relocation displacement. That's this magic number here. Sure. Okay. And now, with these object files, okay, hold on. Why do we have .L0 not being removed? Because it's a relocation. Well, you know what we should do then? So .L0 isn't being removed because there is no relocation we're generating with .L0 in it, and that's the only time we add this to symbols to remove, and etc. So instead of keeping track of which symbols to remove, I think it's actually already pretty clear which symbols to remove. And in fact, we can loop over all of the symbols . Yeah. Okay, yeah, we're going to be doing this a little bit differently, but it's still going to work, so don't worry about it. We're going to be looping over all the symbols and then removing all the symbols. So let's put it back to what it was, because hold on. Make sure it's still working. Okay. We still have this pesky .L0 because it's not referenced. So one thing I'd like to do, remove local labels after resolving the relocations. So first I'll say what we're doing here is resolve local label .lxx relocations. We're going to remove those relocations as part of that thing. And then we're also going to say remove all local symbols, local label symbols .lxxxx. Which means that we're going to be building this symbol to remove index. So we're going to loop over each symbol. I'm not sure why things aren't indenting properly. This is a true mess. I don't know why this is such a mess. Jeez. Okay, that's better. Had to reload the whole file. So for each symbol, if the symbol, right, if our little ditty comes true, if it's a local label, if it's a local label, add it to the symbols to remove by using vector push macro on this vector of this index. And then move on. Now, in reverse, please give me these indices. And do this thing in them. Oof. And then this is a pointer because of our for each, how our for each thing works. And now this is mad because symbols to remove. Because we now have two symbols to remove. And instead of doing that, we can just do this. Beautiful, beautiful. And now when we do our object dump, it won't be so ugly. Yeah, no. Oh, that was on a.exe, which I haven't regenerated. I was like, no, what have I done? But it's fine. We did it now. There's no labels. Okay, that makes me happy. Okay, what have we done in this scenario? We basically just handle local things by hand. So in the generic object file portion of the x86-64 backend right now, this is what I was talking about. We need to have an architecture completely separate from the backend. But it's not right now. It's not. Manually resolve and remove local label relocations. Coolness. And then we're going to fix this little bug here. Also in GObject. Fix bug regarding IR integer literals. Initialized integer literals. Sure. Okay. Earlier I did this off stream, but I made it so that when you're doing function arguments many, it now should work. That's a test, which is why it's not here. Function arguments many. Okay, this is good. We can do more assembly. Function arguments many now properly passes 8 registers using the mswin calling convention. When we weren't before, we were doing an extra. Basically, we were pushing a pointer to an integer instead of pushing the integer on the stack. Hopefully that makes sense. And we have an unsupported instruction in immediate to mem sub. So let's get ready for that. Let's go do that. We need to find sub. These are alphabetical. So I think it's M through U. There's going to be S in here somewhere. QRS. And then it's a U. SH, 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 SL, SQ, ST. Oh, I'm so close. Subtract, pog. Sarade says arguments on the stack work now? Yes, they do. Yes, they do. I mean, arguments that aren't aggregates on the stack in the MS-Win calling convention. Okay, anyway, subtract. We need to subtract immediate to mem. So we have an immediate, it's going to be these ones. We have an immediate 8 that we want to subtract from something. Oh, we don't want these ones. We want the matching size. These ones. There we go. And they're MI instruction or operand encoding, which means that the read-write register goes in RM in the mod RM bit, and then there's an immediate that follows. Cool. Let's go take a look. This is in immediate to mem, it said. But yeah, we now have arguments on the stack, and we also have a lot of things working. We did the local label. I don't know how long you've been here, Sarade. You may have been here the whole time, just lurking. But we now no longer have local labels in the output, and we do our entirely custom local label resolution right here. Pog, 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 yes, yes. It's super nice. And that also means that when we disassemble, then the calls and jumps go to the proper place, as you can see, because this is where L1 would be. That's the start of the move test jump if equal, and jump at 8C goes to here, which then exits. Poggers, so cool, so cool. Switch size. Is there a size? We don't have an immediate size, which is kind of rough. What size? Immediate. So I guess we should just try and use the smallest immediate possible. But for now, we're just going to go with... What are we meaning? How are we using immediate to mem? Why does immediate to mem not take a size? Sarade says, I see we're defaulting to just always emit 32-bit jumps for now, from what I could tell. Yep, that's also what I did the last time I had to generate bytecode manually. Honestly, it wouldn't be too difficult at this point to go through and alter the code and to have a relocation type that means that will like replace the surrounding opcode with a smaller thing if the offset is within bounds. Does that make any sense? Or we could do it where we go through and calculate the offset of each label beforehand, before actually doing everything. But that's kind of impossible. So yeah, 32-bit jumps. We're just doing near jumps all the time. That's kind of our tactic for now. Sorry if that was loud. I bumped my microphone. It looks like we're always meaning 64-bit. So to do, we should really pass like a size to this. But we're just going to assume our 64. So for move, R64 sub, when we sub an immediate 64, which we can't do, an immediate 32 from a 64-bit place, it's a rexw 81/5 id. Now, as far as I know, /5 means that this goes in the mod RM register field. So we're going to have a mod RM byte. And the register field is going to be 5. Also, this is sub. I don't know why I'm crazy. The mod RM byte. This is memory that we're going to be going through. So it's probably an offset disp32 or something. Does it go immediate displacement or displacement immediate? It goes displacement immediate. Okay. And then RM is going to be our actual register that we're subtracting from, I would say. Our address register. Okay. We need rex.w. We need the extension of the RM field in B. Uh-huh. So we have the rex, the mod RM, and the opcode. And then we have the actual displacement, I would say. Yeah. Whoops. What is this for? Sub. Okay, well that worked apparently. Oral? Huh. Not sure if that's correct. What is oral happening here? 8148 AC. That suspiciously looks like this. Oh, this is in the wrong order. Lol. The rex is a prefix byte and goes before the opcode. Silly boy. That looks much better. That looks much better. It's not correct yet, but it is much better. This is looking worrying. New assembly instruction just dropped. Lamau. And then this is /ID, so the immediate byte. So the mod RM, I see what's going on. So we have the immediate, then we have the displacement. This is different. And it goes displacement immediate is what we determined, right? Displacement immediate, yes. I could just do this as well. I mean, it's always going to be 4. Whopper System 1, thank you. I'm going to do that a lot. Okay, we're getting closer. We are getting closer, folks. So we have sub, this immediate, which is incorrect, it seems. Or something of some sort. From this off of rax 1. That seems so incorrect. What's happening here? We have rex.w, plus 81/5 ID. ID refers to a 4-byte immediate operand to the instruction. And then slash a digit between 0 and 7 indicates that the mod RM byte of the instruction uses only the RM operand. The reg field contains the digit. Yes, it does. So what should this be? In code.s, what are we seeing? So we're saying sub 32, 0 off the stack pointer. Sub 32, 0 off the stack pointer. What's the issue? So what should this sub instruction actually be? It should be 83, hold on, what? So they're just using a smaller immediate. Okay, that should be fine though. Whether we use 81 or 83 shouldn't matter. Because the mod RM byte tells us we need the displacement. It's 0 off of RSP too. If it's 0 off of RSP, then that means we can actually use a different mod RM and everything. Because we don't actually then need the displacement at all. We can just use 0, 0. What is that? New x86-64 register just dropped. You've heard of racks. You've heard of RDX. You've heard of RBP. Get ready for Riz. R-I-Z. What is that? The hell? Riz. Sam CPL30, I missed your follow. Thank you so much. Riz. I don't even know what Riz is. Assembly hotfix 0.1. And what are we supposed to be subtracting? Why do we have OX55 blah blah blah? What is it supposed to be? Isn't it supposed to be 0? No, subtract 32. That's OX20. Which is what's here. So 4881 2C does not work. I can't help but notice 81 is not anywhere here. 48, 8D, 5D, F8. Where's the subs? Am I crazy? Oh, this isn't main. Subs. We're using subble. We are using subble. Subble is actually, yeah, these bad boys. Why? Why? So immediate 32, we have 81 /5 ID. ID is a 4-byte immediate following the thing. Apparently, okay, what? So it says that's the 0 register that's always 0. What? I don't think it's an actual register, but that's some obscure stuff. Apparently its actual use is just in disassembler output to signify that a SIB byte has been used when it wasn't necessary. So it thinks there's a SIB byte happening. Why does it think there's a SIB byte happening? What? How do you even signal a SIB byte? I don't think I've even gotten into that. It's required. Does that mean that it's like it's required here? They'll tell you if you need a scale index base? I don't see anything here. Okay, well. Certain encodings of the mod RM byte require the SIB byte. The SIB byte includes the following fields, see section 2.1.5. Oh man. So when do we need the SIB byte? With the SIB byte. It's got to say it somewhere. If the instruction does not require a second operand, then the reg field may be used as an opcode extension. Yes, this is represented by the 6th row in tables, labeled digit opcode. Yes, so if there's a 5 there, then to offset a DISP 32 from ESP, we can't do that. So stack pointer isn't encodable. So we need stack pointer in the RM byte. So we have stack pointer here, but that means that this is 5, and with OB00, why is there this? The nomenclature means a SIB byte follows the mod RM byte. 2.1.5. I don't see that. So how can I do this without a SIB byte then? Because because this is reg. So if reg is 5 and mod is 00, mod can be anything and it doesn't matter. Do we need to use mod 11? You know, when in doubt, what I usually do is just assemble the instruction with nows and whatever. Yeah, I already did that. It doesn't help. They're just using a different opcode. See? They use sub L because the immediate is 1 byte. But that does, we should still be able to make a subtraction with an immediate larger than 1 byte off of RSP. So they're using 83 2C 2420. So we have 83, the opcode, 2C, which is probably the mod RM byte, right? What is 2C? 83 2C. That's the immediate byte that follows the thing for this thing here, right? 83/5 IB. So Well, then tell it to assemble a sub with an immediate that actually requires 4 bytes. I don't even know how to do that, man. So what requires more than 4 bytes? I feel like I can do this. That number should do it. Operand type mismatch for sub. Well, the problem is it can't do 4 bytes, so it's going to have to be less than that. So it can be 4. Okay. Now subtract some large number from RSP, and we get 81 2C 24. And when we do it, we get 48 81 2C. So we have a prefix byte that they don't have. Is that true? They don't have a leading 48 for RSP. And then they have 2C and 24. And we have 2C and 20. That's fine, because I just changed the one that was 24 and not 20, but whatever. What's kind of worrying is that this one works. What's this happening? The 20 is the immediate. Yeah, NASM has 81 2C 24 plus 4 byte immediate. 81 2C 24. So they have a scale index base. You're doing 48 81 2C plus immediate. So they're just including a scale index base? Is that what's happening? How do they know to do that? So I'm doing a sub Q versus a sub L. I think that's fine. So I think the 48 can stay. However, there is a clear issue with me missing the scale index base byte, which is why it's assuming the next one is. So if I literally just did this, this is not the solution I'm going to stick with. I'm just seeing if this works. That is now working with an extra with an extra byte. Oh no. Okay, the extra byte is just on a new line. It's not an extra byte. That's fine. That's because of the prefix, the 48. Maybe. I think it's just on a new line. I think everything's actually fine. I think it's just because it wouldn't fit here, so they're putting it on a new line. There's no instruction. It's not a NOP, right? If this was like a new instruction, there would be NOP here. But there's not a NOP here. It's just part of the sub queue. So it says, yeah, it is just on a new line. Legendary, legendary. I was worried that this was like NOP instructions, like null bytes in the middle. I was like, oh, no. No, no, no. Well, that's working now, but why? What is OX24? And what is a scale index base byte? I haven't looked into this at all, because I haven't needed... What is this even used for? So you have like a base, then you add to it, and then you add a displacement to that? Oh, here, this is better. So EAX times 4. What is happening here? You just multiply something? Why would you want to access the multiplication of something? Am I missing the meaning of this? The star nomenclature means a disp32 with no base if the mod is 0. Otherwise, star means disp8 or disp32 plus EBP. What? Sraid says, array indexing, that's what that's for. How does that help for array indexing? Like, let's say you have an 8-byte element. What would you do? How does EAX times 8 help you? Because you can't store the address, so you'd get the index. Okay, I'm starting to get it now. I am starting to get it now. So where's scale index base actually? Do they talk about it at all? ModRM and SIB bytes. This is it, huh? The base plus index and scale plus index forms of 32-bit addressing require the SIB byte. Where's the layout of the scale index base byte, by the way? This is the modRM, clearly. So we're doing 4 to get ESP, but then we have 5, 1, 2, 3, 4, 5 here, which is disp32. Table 2.3, I think, so next page. Value of scale index base byte. So what's 24? We know 24 works. Why does it work? 24. ESP. 5. Okay. Okay. This is odd. So we have the 5th thing here, which I guess the index 4, right? Why do we have index 4 here? And why do we have index 4 here? Or do we not? What do these mean? Scaled index, SS index. My brain is breaking. Why does this require a SIB byte? This requires a SIB byte because the modRM byte has ESP and 5, but 5 nomenclature means a SIB follows the modRM byte. So we have to write a SIB, a scale index base byte, following the modRM byte, and apparently it has to have 4, 4? And SS00. So the star nomenclature means a disp32 with no base if the mod is 0. Otherwise, star means disp8 or disp32 plus EBP. It's explained on the paragraph on the page. Is it? This thing? Okay. General purpose registers used as a base are indicated across the top of the table. Okay. The corresponding values for the SIB bytes base field. Okay. Table rows in the body of the table indicate the register used as the index and the scaling factor. Okay, I'm now getting it. I am now understanding. So it seems like we're going to need a sib byte helper, very similar to the other one. To borrow a phrase from Magic the Gathering. Oh? Reading the manual explains the manual. Lamau. Okay. So as a base across the top of the manual, sorry, do you know if it's just like this one crazy scenario that does this? Or is this just like how it works? Do we need a scale index base for OX81 all the time? And if so, why? So OB00 in the mod RM bit is probably causing it to need... So this 5 in the register is causing it to need a sib. But if that was the case, wouldn't this one need it too? Well, I guess it might. We're not running into this code. Let's try running into that code. Because again, that's another thing that should work, but doesn't necessarily. I think it may just be for ESP. Yeah, so we're doing that wrong. Because we need mcode 4. Okay, we can at least do that. That is working. That's a huge opcode. Oh my god. Oh, I have to go soon. Oh, it's so late. Shit. Okay. That's fine. Okay. I'm so late. I think it may just be for ESP and EBP. Why? Why would ESP and EBP be different in this way? We have ESP here. We have EBP here. Why do we need the SIB? I think it's just an implementation detail, perhaps. Okay. I just want to know, like, where actually tells us when we need a SIB or not. When is a SIB byte needed? The values that would be used for ESP, EBP are used for something else, so we need to encode ESP, EBP differently. Huh. You're sounding very right. base reg plus index reg times scale plus displacement. Sure. This is not helpful. Segment overrides. Okay, I'll get there, don't worry. Okay. What is this trying to tell me? I'm looking at a large table and I don't know what it means. So with mod 0, if we want to do the stack pointer, with 5, then it's base. Well, that's what we want. But there's a note. Just it links to the manual. For fuck's sakes. Sraid says he actually went to the crazy optimizing assembly link that I was scared to go to. He says page 25. SIB byte. The SIB byte is used for memory operands with complex addressing modes, and only if there is a mod reg rm byte. Oh, I have to go back. I'm so interested in this. A SIB byte is needed in the following cases. I'm just going to copy this. Be inspired by this. Okay. And then that goes up. Okay. If a memory operand has 2 pointer index registers, what? 2 pointer? If a memory operand has a scaled index register, if a memory operand has the stack pointer as base pointer? As base, if a memory operand in 64-bit mode uses a 32-bit sign-extended direct memory address rather than a RIP relative address. Does that ever happen? Oh, God. Okay. C is exactly what I was saying. Yes. Yes. Okay, so that means that... God, that complicates so many places. Oh no. So it can very well be that the manual just doesn't explain that. It's just implied. Ah, yes, naturally. What's the SIB byte gonna even be? Wait, hold on. It's gonna be a scaling factor of 1, an index that's not used. I'm trying to think, what would OX24 even be? OX24 would be this number in binary, which means that we have 4 in the last one, which is going to be the reg bits. Are they both address reg bits? I think they're both address reg bits. Maybe I'm crazy, but I feel like that's correct. I feel like there should be a function for that, like encode memory operand or whatever. There definitely should be. because we're probably going to need that all over the place. Yep, so a separate function could deal with whether or not we need a SIB byte. Mafaniaka Mars 10G, Morglod, Louis Rebiacado, and Mitensis. Thank you so much for the follows. I appreciate it so much. We are now over 500 followers on Twitch. Be sure to check out the youtube.com/@LENSR, LensR. Go and follow me there to see all of the VODs of streams and maybe some educational videos. So it says no 100 means no index register. Does it really? I'm just gonna do this. Scaling factor 0, 0. Scaling factor equals OB00, 0, which means 1. Index is equal to OB100, which means none. And then base is equal to RSP bits 4. Thank you, Saraid. So encode memory operand would take way too much stuff. Wouldn't it? I just don't even know what that would take. Like where would that function actually go and what would it replace? Do we want it to actually write things? If we have it actually write things, then we would want it to write the mod rm and possibly the SIB and the displacement and, no, not the immediate. So we'd want to do all this stuff through encode memory operand. I mean, I feel like that's a good idea. I just don't know if it'll work. A little scared, to be honest. Okay, so now let's make sure that this still works. Now we have 0 off of RSP. Now we can shorten these up a little bit by saying if the offset is 0, then go ahead and use a shorter instruction. And this thing. Sub off of RSP directly, that's very nice. And we could even go further. I mean, we really could go further and say if the immediate is small enough, then we could deal with it. So this is going to be OX81/5 ID. Right? Sure. Yeah, we could make this even better if we wanted to, but we don't have to. Well, poggers. It compiles. Ooh, it doesn't quite run. Yeah, we have a problem somewhere. What's our problem? Function arguments many. Does like code.s works, right? Code.s works. 69 plus 69, as far as I'm concerned, is 137. It's 138. Uh-oh. Oh, I have to go so soon. So I'm looking for function arguments many. Oh, I guess I don't necessarily know it's 69 plus 69. I might have screwed this up. Here, I can actually just do this. It is 137. Legendary. Or at least according to Emacs, it is 137. So, if it is in fact 137, we'll make it 138. Okay, that works. But if we take a look at our... Yeah, it doesn't work. So something's different. What's different about our silly little Billy? Seems like there's a lot of popping going on here, and not a lot of pushing. Oh, here's all the pushing. Push, 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 push. Call. Pop, 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 pop. Why are we adding OX40 here? Why do we sub 20 and then add 40? Is that correct? It is correct. We sub 32 and then we add 64. Oh, because we're pushing RBP in between here. Silly me. Okay. So now we're subbing 8 off of RSP. That's fine. Is this different? Am I crazy? We have sum, which needs relocated. It's not actually showing the relocation here. That's a little worrying. Oh, I'm missing stuff. Lamau. Gotta love it. Somehow chat froze. Sorry, it says an ESP and the other, so they just happen to both be 100, or is it just me with this on-screen chat stuck? Gimiranda says, what is the use of this compiler? You can use it to do whatever you want to do. You want to do something that might break the stream? I've got to go soon, so why not, right? Thanks for letting me know, guys, that the chat wasn't moving, by the way. I appreciate that. Sorry, it says question, how are we supposed to tell you that chat is broken if chat is broken? I tried pinging you on Discord, but to no avail. That's a good point. I don't know. I'd have to figure that one out. Legendary. Hey, Wadi, thank you so much for joining the Discord. Lamau. I don't know, honestly. Okay, Saraid, if you called me on Discord, then it would like ring, right? And it'd be like, oh, Saraid's calling me. What the hell's going on, right? So it says, I can just call you next time. Yeah, sure. Legendary. Because it's hard for me to... I don't know how else I would deal with that. I need like a way for you guys to ping me. Like, just make a ding. I was about to do that before you scrolled up, lol. Legendary. You're amazing. Adoradov, the Rain Man, thank you so much for the follows. I appreciate it. So let's go through here and figure out what might be different from code.s. in main. We push ribipa, we move risp ribipa, we sub ox20 risp, we push risp, we push ribux. Hold on. Stop. We push risp. That is not correct. We should be pushing R12. What is happening here? Damn it. Damn it. Why? Why hath God forsaken me? Last I checked, RSP does not equal R12. Verlio says, I wonder if it is possible to send the bell character in Twitch chat. That'd be good. That'd be really good. Seeing as it's a 64-bit only register, probably missing a prefix or something. Oh, I am. I am. How do I even do this? Okay, I know how to do it now. So, what do we call this register? And then this is going to be a Rex byte. Just call it error code 5, easy. Golden Lion says, do you do advent of code? Yeah. I don't like make sure, it's not a thing, but I do it every once in a while. Verlio says, I tried, message didn't even show up. Rip. Advent of code and intercept. Ooh. That's actually possible this year. That's actually possible. Yeah, we should do that. Saraid says, oh, by the way, Egner Fogg's manuals don't cover everything in the same way that the Intel manuals do, but they explain some stuff a bit better than the manuals IMO. I'm going to keep that tab open. I want to read that because it looks pretty nice. If you send a message with just the bell character, it will look like it's sent, but it won't actually send. Crazy. Craziness. Where's the top bit of this register set? RD encoding. Chapter 3. The lower 3 bits, okay. The 4-bit field of rex.b. Okay, so rex.b makes it larger. Oops. Wrong keyboard layer. Hey, that's better. That is better. Flays. Saraid. You like Flays? Flays is a good one. Gmoranda. I'm trying to create my own domain-specific language to make text RPG games, but I'm struggling. That shouldn't be too hard. I mean, it is going to be hard. I'm not saying that it's easy. Davros1, thank you so much for the follow. Davros1, compiler dev, what are you compiling here? It's intercept, my own language, so we're actually compiling the, I think, while function arguments many. So right now we're doing this test. But yeah, this is the intercept code. It's meant to be particularly bad, as in, like, nobody would ever write code like this, but you're just meant to test that there are many arguments to a function, and it works. And we're compiling this little example. You see all the IR flash on by, and then we are actually currently testing the object file backend that generates both COFF and ELF object files for a program. And we just wrote the assembler to actually encode this sub instruction from RSP and friends. And then we fixed a bug with push regarding missing a rex prefix. So yeah. Rohan, compiling hopes and dreams and error code 5s. That's right, Rohan. It's so good to see you around again. Gomaranda, I missed. I didn't. Okay, Davros says, I'm just trying to resist starting an ad hoc Lisp for game scripting myself, but there I'd just be interpreting. Interpreting and compiling are kind of two peas of the same pod. Gamaranda says, my struggle is to make C more generic so the user can modify the game logic and add its own game logic. That's not really, that doesn't have anything to do with generics. In C, you could accomplish that by using a function pointer and a struct and have your game basically be a structure of function pointers, and one of them is like attack, and then attack may be replaced with a different function by the user or something like that. And then you could create C functions based upon a DSL, clearly. Ataradov. Did they ask a question? Am I crazy? Maybe I'm crazy. I don't know. Oh yeah, do text RPGs need to compile down to assembly? Sorage says probably not. Gamaranda says, no, my idea was to make a language for that would transpile to C code that would be compiled to the game. Yeah, you can definitely do that. Sorage says you could use C++. You could. You can write it in any language you want. That is true. That is true. We've done some assembling, so let's do some assembling. I wonder if I made the same mistake in pop. I bet you I did. I did. Even has the same incorrect comment. There we go. Okay, push and pop. Bugs with push and pop. You could also create a good API for your game and expose functions which can act as blocks for users to build. Yeah, that's kind of what I was describing as well. Commander says, how? It's a good question. Adding to what Isidir said, I have seen games use Lua to extend games. Think WoW also did the same, but I can't be 100%. Yeah, you can literally extend games in any way. Gumaranda, Davros, Ibergagiglia, thank you so much for the follow. And just new, Patrick Lorero, 01, thank you so much. x86-64, fix encoding of 64-bit registers in push and pop. Lua is fairly easy to embed if you're going for that. I mean, yeah, so is Python, so is Lisp, so is anything. Embedding is easy. Embedding is easy, I promise. Whereas embedding V8 is like 200 to 300 lines of code to execute one line of JavaScript. Yeah, that would be rough. HTML is not bad too. I don't know if that's a troll. GJ1118, thank you so much for the follow. Coolness. Oh yeah, this might like break my computer or my stream. So if I'm all of a sudden not live, it's because I'm trying this. Let's do the SDL example. We don't have and yet as an instruction. That's okay. I'm kind of curious if it works at all, even without machine code or anything like that. Because it hasn't worked for a little bit. But it finally compiles. We can link with SDL2. And now, here we go. Okay. Okay, I don't know what happened for you guys, but for me, that was crazy. What did you guys just see? So it says black screen. All right. For me, my entire monitor goes into like 640 by 480. So it says, I think we saw your desktop in the top left corner, but that was it. That's what I'm seeing. That's what I'm seeing. All I see is my desktop, but really big, because I'm pretty sure we're going into like, I don't know how it works. Oh God, black screen again. Just from closing it. I think we have like a very, because we're passing 0 for flags, I think this is our issue, right? So I think we need to find some flags for SDL that aren't 0. SDL window flags. Yeah, that small desktop that I was seeing, it was like just a square in the middle of my screen. What is the actual value of this, though? I need to know the value of this. There's not like an enumeration, a source code link. There's not a, nothing like that. We have set window full screen. I don't feel like that's going to help. SDL2 window flags value. So it says, I can tell you the value real quick. Oh no. Yeah, the values aren't here either. I can just put it in my C++ REPL and it'll tell me what it is if you're interested. If you can try, I'm going to try and use GitHub to search for it. Okay, I found it. I found it. Legendary. What do I actually need? SDL underscore window. Let's do resizable, OX20. Can we do resizable? Let's do that. Kind of like the idea of that. Okay, here we go again. Cool. Yeah, so this is weird. This is very low resolution. I see, I don't know about you, this is the top left of my monitor, and this is the bottom right down here. Craziness. Can I close this, please? Why is it going full screen? Oh no. Stop. I'm gonna like leak my IP somehow. Okay. The wallpaper is crazy, Lamau. I'll have to show you. Okay, I'm just using STL window shown for my STL2 game. And it doesn't do this, right? And maybe these are incorrect because they're STL3. Can I go to STL2? Well, clearly it's not found. It's in STL3. I slept and you are still live, Pog. I mean, I have to go, but yeah. I have to go like now, actually, but... Yeah, resizable is still OX20. OX04 would be window is visible. SDL window shown. Let's try. Nope. Still crazy. Still crazy. Still sets my full screen resolution. Oh, rip. Everything gets so ruined. Oh, man. Well, we're not quite there. But we are getting there, so that's huge. The man says, why? I know SDL2 will make your screen flash black when you start exit a program on Linux unless you turn off a setting. Yeah, it's probably whatever that is. By the way, early return really cleaned this up. It's looking much better. Okay, another thing I would like to do with the machine code disabled is run ctest. we just have what looks to be a few failing tests. That's looking good. And you can see that now function arguments many is passing. So we now only have 4 failing tests, aka 4 out of 94. 96% of tests are passing. How pog is that? How pog is that? So it says, I don't know why that would be happening on Windows or how to fix it. Yeah. Azish says, good luck, it'll work. Think of your game API as Lego bricks and expose the blocks to users. And document. The worst part is documentation, in my opinion. Not 100%, so no pog bones yet. Lamau. I don't know, it's not too bad. I'm pretty happy with it, at least. Yeah, and they're just the regular bugs. I'm sure if we do machine code, you'll be able to actually see all of the places where we can't emit machine code. There's actually way more passing than I thought. There's 65% of tests passed. God damn. That doesn't mean we're assembling them correctly, but it does mean that something's happening, right? I am not a good programmer in C. I need to get it better. Then code things. The only way to get better at something is practice. For example, they say basically everything except riding a bike you get worse at. Unless you do it all the time. Right? Like, if you don't add numbers in your head all the time, then you're going to be worse at it. You're going to get slower than you used to be. So it looks like we don't handle multiplication, which is a big deal. We don't handle string literals, which is a big deal. We don't handle and, which is a big deal. We don't handle shifting, bit shifting, which is a big deal. More multiply. We don't handle X. So basically any of the bit operations we don't handle. We don't handle XOR, and, or shifting, etc. So we got to do all that. And then we have and IML and unsupported instruction 20 call in mcode indirect branch. Just gonna check on that one. Okay, we don't support indirect branches at all at the moment, so that's legendary. That's definitely something we need to do. We need XOR. Why do we need XOR so much? What are we XORing? Oh, we're zeroing out a register with XOR. Rohan says, so it is a good time to implement them, Bog. I mean, I have to go, but yes, it is. I'm going to be doing this tomorrow as soon as possible. Isidish says, also, yep, +1 on what Len says, just build things. Thank you, Isidish. It's true. You just got to do shit. If you want to be a better skateboarder, ride a skateboard. You know what I mean? I know it sounds too simple to be true or too good to be true, but it is true. If you do something, you'll get better at it. Well, that's fun. We aren't doing too bad, even with the machine code. It looks like we just have some arbitrary instructions to implement. I have to go. Oh, don't leak DMs. I wish Discord streamer mode made it harder to leak DMs or something. But yeah, so we now have a compiler that when you invoke it, let's, for example, run like simple pointer or something, right? When you invoke this compiler, it can now generate, as I said before, and I'm sure everybody is tired of hearing, ELF and COFF object files, which contain machine code assembled within intercept compiler. And we can take a look at that if we disassemble it. And you can see that there are these things, relocations, where we're offsetting 0 off of RIP, and these relocations tell us that, hey, we actually need to alter the data here before moving on. For example, when we use GCC to compile out.object, and then we can do object dump on our resulting a.exe dash disassemble on our resulting a.exe, and you can see that these have been filled in with references to the variable number, and it is different numbers each time because it is a RIP relative offset. As well as that, one cool thing we did today, I think, is if we do greatest common denominator, and then do the whole shebang for things like that, then we can take a look at the code here and see that we actually, if we take a look at the assembly, you can see that there are these labels like .l0, .l1, etc., right? And we jump between them. So in order to do these jumps, you may know, it's not main, it's actually this thing. It's not that thing. It's, why is it not that thing? Oh, because this. As you can see, when we jump to 7a, which is now properly, as you can see, we jump to L2 here, which is just the next instruction, so we don't actually do a jump. But we jump to 7a, which is the proper offset for where we should be jumping, and for jump 149, for example, to jump L7, then you can see L7 is down at move RBP RSP pop RBP ret, and if we go to 149 over on the left here, we have move RBP RSP pop RBP ret. So we are manually inserting these offsets so that these jump instructions work properly, and we can jump around all of these files. Look at us split. That's a good question, Miranda. But if you if you have to ask that question, then you don't need the answer. And if you don't need to ask that question, then obviously you don't need the answer. So it says, I don't know. Exactly. That's a good answer. Is it used as Pog? Thank you, thank you, thank you. It is Pog. It's so cool. Verlio says, kind of like, or Miranda says, kind of like what Zork did. I don't know what that is. Verlio, okay, but Mach-O when? Shaking my head. Okay, I have developed this stuff so fast. You don't even know, son. When did I start this? I started this 2 days ago. 3,000 lines of code 2 days ago. Okay? I'm tired. We'll add mock.o when my hands recover from the carpal tunnel. I was wondering why I didn't see the most recent push. And there's more stuff. So what do we have? We create the local symbol, which is funny we didn't do that earlier. We should have, but it's fine. Create symbols, create temporary symbols for local labels. Scale index byte helper, scale index base byte helper. Jomoho Games and Nate Lift 151, thank you so much for the follows. And also Frango Molhado, what a fun name. Scale index base byte helper. Yeah, I'll get to there. Sema prevent null dereference. Not like semantically in intercept, just prevent a null dereference within the type checker. Probably could have been more clear on that. Uh-huh. GJ1118 says, thanks for the stream. Loved it. Thanks for the quality time. Must get back to real life now. Thanks for everything. See you later. Have a good rest of the day ahead. Thanks, GJ1118. You have a good time. Feel free to message me on the Discord or anything. I'm done to talk. And be sure to just join the Discord so you never miss another announcement when I go live. How about that? How about that? I would appreciate it. MS Win. Bug fixes that allow for stack-based arguments. Cool, 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 cool. And then we have some new instructions that we wrote today. More machine code encodings. We have sub in immediate to mem form and move in reg to name form. Yeah. Good Miranda says, thanks for the stream. I'll be back. I appreciate it. I can't wait to see you again. What else do we have? What else do we have? I didn't really change much else. Legendary. Okay. Okie doke. Oh, bog. We are all caught up, pushed into the repo. Feel free to check this code out. Be sure to review it if you have 3,000 lines of code worth of time. I would greatly appreciate it because I'm sure there are bugs. I have written this code in 2 days, and it's a lot of code, and I'm one person. I don't get everything perfect. Range Bomber says, you have a nice voice. Could be a voice actor. Take energy. I would love to do voice acting. That would be fun. That would be a lot of fun. Fuck me. K lines. 2K lines. Yeah, it's 3,000 in 2 days. In 10 files. 50 commits. Most of it's in one file. You can see 1,800 lines in one file. But I also wrote generic object, C and H. Generic object.c is 500. Yeah, I've done a lot. I can't even make 100 lines in a week. Well, the good part is that the quality of code is not determined by lines of code. If it were, bad code would be better, right? So if it takes you longer to write code, I wouldn't worry about that because the quality of code is different. I'm not going to lie, all of this code sucks. The first sentence is, I'll start by saying I don't even know if this will end up getting merged. The code is quite messy. right? My goal is like, I don't know, flick the paintbrush on the wall. Maybe it'll make something cool. It's a hackathon quality code. It's a little better than that, but yeah. A hackathon, you don't do anything. But for example, we're calling strdup, which allocates memory, and we're never freeing this. This never gets freed, ever. We're just leaking memory here all over the place, and there's strdups all over this file. Look at how many there are. How many occurrences are there? There are 46 occurrences of strdup. There are 46 occurrences of a horrible, obvious bug in this code. This code leaks more than Google Chrome then. Well, that's the thing. Each of these is like 30 bytes, so even total 46. Let's say it gets called 1,000 times. 46,000 times 32 is 1.5 million. And then if you divide that by 1024, you get kilobytes, which is 1,400. 1.4 kilobytes of memory leak is not that big of a deal. Even if this code gets called 1,000 times each time you see strdup here. So if each time you see strdup it's being called 1,000 times, then we'll leak 1.5 kilobytes. I'd love to know why Chrome leaks so much. I mean, it's exactly code like this. It's just with larger stuff. You know what I mean? Sraid says, I'm going to take a look at reviewing this. Oh? You are? You don't have to. It's a bit rough, man. It's a lot of code. Those are a lot of commits. RIP. Well, that's funny. When you use the eyes emoji itself, it doesn't actually show up in my Emacs. Because I don't have emojis in this font for some reason. I tried to get emojis working in this font, but I can never get it. I can pass Sonar Cube in this code. I don't know what that is. What is Sonar Cube? If this was porn, you would have just got me. I just realized if that was something bad, you just made me Google it. Damn. I see. Code quality performance. It's static analysis. I got so worried there. As that page was loading, I was like, oh no, I'm gonna get banned. Okay. Okie doke. SDL2 weird full screen. That's something I gotta figure out. This is the Wagner stuff, right? Was that his name? Egner Fog. I don't need this anymore. I do need this. I do need this. I need this. Not this. This I need. ELF. I'm doing okay on ELF actually. I don't really need ELF open. This ELF spec I want to save. Here's the mod RM X. Yes, and then this. Okay. By the way, if you check out the description, if you're watching this, there will be a ton of links for all these references that I'm going through and stuff like that. So be sure to check that out. I'm gonna do my little spiel and then I'm gonna go. Sraid says, I just use Valgrind usually. I like Valgrind as well. Miranda says, I wouldn't do that. I'm not that monster. Is it you? Says Egner Fog? That is what it sounds like. This guy. Egner. From the Technical University of Denmark. The Netherlands. Cool stuff. This is definitely less of a work in progress now, by the way. Cool. Am I somehow getting this one? Might somehow be getting this one. Denmark is not the Netherlands, lol. It's right next to it, though. You have... What? You have Denmark, and then you have the Netherlands, if I'm correct, to the west. If I'm correct. You have like a bigger kind of Netherlands thing to the north of Germany, and then you have Denmark is to the west of that. I don't know. So it says you're very much incorrect. See? It's not adjacent. It's got to be at least close. Take your look at a map. No. Okay, Suraid. Rohan, I want you to tell me, is North Dakota adjacent to South Dakota? Wait, that won't work. Damn. No, I'm kidding. Don't open maps. Yeah, I'm not going to Google Maps. I'm going to get in so much trouble. Suraid says yes, probably. Lamau. Here's Denmark. Oh, I'll click on that link. Okay, hold on. What is happening? Why just happened? Okay. Hold on. Hold on. This is Germany. No? Is this France? This is France because this is Calais. This is the... Google Maps is a bad thing to show on stream. The licensing is tricky. Germany is in fact south of Denmark, yes. Okay, just checking. This is Germany, this is Denmark, this is the Netherlands, because Amsterdam is here. Yeah? This is Belgium. This broke. Rohan says, nope, I was close. Good God, no. Well, listen, just imagine what you know about America. That's how much I know about the EU. That's Poland. I thought Poland was invaded, wasn't it? No, I'm just messing. This is Poland? So if the Netherlands isn't on the coast, is it on the coast and it's way up here? I don't even know. The good part is I don't care. Just the same as you don't care if Washington is close to Utah. It doesn't affect you. Because people do not know everything, even though they like to fool you. Okay, yeah, that's for me to figure out. I am all good. I would like you to do something. Type in youtube.com/@lensr. If you type that in, Sraid says, here's another map. I don't need maps of Europe. I don't need to know Europe. All I need to know is like Europe big, Belgium in Europe, Netherlands in Europe, Netherlands, Germany, all kind of close to each other, Denmark, right? They're all very near each other, similar people. They're not similar people as in like culture, but they're similar as in they're both European and live the same way, if that makes sense. They eat food from each other. Same way we eat Canadian food and Mexican food here. Go to Lenser, the YouTube channel. He's this guy. I don't really know him that well, but he makes cool YouTube videos, so you should definitely go check it out. He has like this playlist with a compiler videos, and they're each like 5 hours, and there's 40 of them, so definitely check those out. Other than that, check out the links in the description. Check out the About section to see. Miranda says, Europe makes good chocolate. All everyone needs to know. Not incorrect. Is it he says they eat food? Oh. Turns out they do. But yeah, be sure to check out the compiler series on YouTube. I also do a ton of other stuff, but every VOD I do from my streams is there. Be sure to check it out. And yeah, be sure to check out the GitHub and go compile intercept yourself. The docs are pretty good. They're very simple, not really complicated at all. They don't have the object file backend in them because that is still a separate branch and will be merged soon if I am able to clean everything up. Rohan says, check out the map section to know where the Netherlands are. They're in Europe. They're by Germany somewhere. That's all I need to know, man. Amsterdam is in Netherlands. I know enough to be dangerous, and that's all I need. Because I'm an American. No, I'm kidding. If I ever need to know where the Netherlands is, I'll care. To the left of Germany. So it's above France? Netherlands is connected to France? Whack. Miranda says Merc. Yeah, this is Merc. Around here, this Merc. I don't need no Netherlands is Merc. To be dangerous, yes. Okay, cool. This is awesome. Be sure to check out the description. There's a donate link if you feel oh so generous. I will kindly accept donations, and if you leave a message, I will read it on stream. If you leave it in between streams, I'll read it on the next one. Sraid says, no, Belgium is in between. RIP. That makes sense. That makes a lot of sense. EF Sue says, lol. Anyways, this has been your favorite internet e-clown embarrassing himself for your dopamine and serotonin receptors to receive the nourishment that they need. Thank you for watching. Y'all have a great time. This is very late, but I am going to say goodbye. I've had a great real time with you, and I will see you maybe tomorrow if I can. We'll implement some of the bitwise instructions, the assembly of those. Or assemble some of the bitwise instructions, I guess I should say. And yeah, Poggers, I had a great time today. If you'd like to say anything, now's the time, because I'll be in chat for a few minutes as I wind everything down and upload the VOD to YouTube. But thanks all so much for watching. You guys are the reason I am here, so I appreciate every single one of you. EFSU, Suraid, Izidiuj, Miranda, Rohan. We got so many people in here today. We even had, who else did we have in here? Oh yeah, we had yep. We, Range Bomber, Verlio H, GJ1118. They had to go earlier, but shout outs to them. Molly the Man, hopefully you're still chilling and pogging around here. Gumaranda says, Suraid? I guess. I mean, he's around. No, I'm just kidding. Yes, Suraid. We appreciate Suraid so much for his eternal knowledge and just really generosity for spending so much time and being such an awesome person with this community. But yeah, be sure to join the Discord. You'll get announcements every time I go live, and you can ask to join the notifs. Hi, GJ. Thanks for joining. You can ask to join the notifs group in the general or whatever, and I'll assign it to you, and you will be pinged every time I go live, never missing another stream. That's all the ways that you can contact me. Also, just check out all my connected accounts or however that works. I'm sure you can get them somewhere. And yeah, check out YouTube, GitHub, Codeberg. I made an OS just as a selling point for me. I have an OS, I have a text editor, I have a compiler, I have a bootloader. All of these things I have made, all mistakes I made on my own. I thank you for joining me, and I will see you in the next one. Bye, everybody! I love you. Especially you, Saray.